25, 0, 5, 24. Right? Fine. So take the problem. Take the problem. I think totally 8 nodes are there. Totally 8 nodes are there. Johan Natke. Johan Natke. Shiva Natke. Shiva not came, Johan not came. Today 24. Today 24 or 25. I can verify also here. Yesterday lot of work we done. This one. Where is the yesterday date, yeah? Where is yesterday date? Date not there. It's okay. It's okay. It's okay. Come here. Come here. I hope 25. I hope 25. Am I right? 24. 24. Okay. Yesterday I said, na palindrome. Yesterday I said, is it palindrome? Maybe today morning, I don't know. Yeah, go ahead then. Go ahead. So to this problem, today morning maybe I said, okay, fine. Graph theory 8 classes. Yeah, it deserve. It deserve. After merging, it will become maybe 4 or 5. Yeah, it really deserve because 2 questions will come. 2 questions will come. I think it deserve. Shakir, it deserve. Today maybe last class if everything is fine. Now this is the graph. This is the graph. What is the matching number of the graph? Find matching number of the graph. Find matching number of the graph. Try. Finding matching number of the graph. Let's see how many people will give. Let's see how many people will give. Try whatever you are thinking, you try. So if you are not getting, can you go to previous problem and check? If you are not getting, you can see this problem. You can see this problem. For this graph, it is the matching number. For this graph, it is the matching number. For this graph, it is the matching number. Continuation of the previous problem. Find out what is the matching number of the graph. Yeah, I'm giving the answer. I hope everyone tried. I hope everyone tried. So let me try this. Right? So you know very well matching means, every person degree maximum 1. Right? Every person degree is maximum 1. Maximum 1. And you have to keep more edges. By satisfying that condition, you have to keep more edges. I think, can I do this? Because of totally 8 people. Totally 8 people. This is 1. Right? Every person degree is maximum 1. Maximum 1. Every person degree is maximum 1. So I kept 3. By satisfying the matching property, can you keep more than 3? Is it possible? Can you check? If anyone can try, they can try. Anyone say, sir, possible? Please let me know. Yeah, I think yesterday, Sayan, are you there? Sayan, are you there? Yesterday you said that, right? Matching number of the graph means number of edges present in perfect graph. Perfect matching. Perfect matching. See, perfect matching not possible for this. To this one, perfect matching is not possible. To this perfect matching is not possible. Sayan, are you there? Sayan, are you there? Sayan, are you there? No, Sayan? Sayan not there? Yeah, fine. So to this one, perfect matching is not possible. Perfect matching means every person degree is exactly 1. Every person degree is exactly 1. That is called perfect matching. Every person degree is maximum 1. That is called matching. Right? Next one, matching number of the graph means by satisfying the matching condition, how many edges you can keep maximum. By satisfying the matching condition, what is that one? Every person degree is maximum 1. By satisfying that condition from the given graph, how many, right? How can you, right? Can you draw one subgraph where matching property is satisfied and more edges are there? So I hope everyone got it. Answer is 3. Better than this, if you find out, please let me know. Go to one more problem. When you don't know this topic, it look like very danger. Those people who knows 1 second only or 1 minute. So that's what I am saying. That's what after GATE exam is over, your friend will say answer for this one is 3. You will simply say what is the meaning of matching and all. Right? You could have studied. He got 2 marks by taking only 1 minute. Because of you didn't study it, so you lost it. Just read one time. Just read one time. The definitions only important. Afterwards, 1 or 2 examples you do, you will get the clarity. Okay, one more problem. Can you try? This is also 8 vertices. This is also 8 vertices. This is also 8 vertices. Now, can you try what is the matching number of the graph? Try this. Again, I'm giving 1 or 2 minutes. Try. Can I give answer? Yeah, someone is saying 4 is the answer. Someone is saying 4 is the answer. So let me try. Someone is saying 4. Let me try this. So remember, matching in the sense all vertices should be there. First condition, all vertices should be there. Matching means when you say matching, all vertices should be there. And one more thing is, for the given graph, subgraph you have to take. You cannot take whatever you want in the answer. Matching is a first of all subgraph of the given graph. Next one, all vertices should be there. And one more, you have to keep maximum edges. I can keep 4 people like this. I can keep 4 people like this. Right? I can keep 4 people like this. Right? Yeah, that's it. And one more interesting answer. Every person degree 1 also. So it's a perfect matching also. So answer is 4. Matching number of the graph means how many edges are there? 4. And one more thing is the perfect matching also. Perfect matching means every person degree is exactly 1. It is a perfect matching also. With just definitions only, just definition and common sense. There is nothing extra required. Definitions, first of all, understand the definitions properly, use common sense. Right? Fine. If you okay, you also said one point regarding odd vertices. Perfect matching are not possible. Can you say it once again? Yeah. Can you help me? Can you help me one small line? See this one. I think if you see perfect matching, observe here. If you see the perfect matching here, see this one. 2 people, 1 edge. 2 people, 1 edge. 2 people, 1 edge. 2 people, 1 edge. Let us assume that one more vertex there. Let us assume that one more vertex there. Can you say perfect matching possible? Totally 9 people. How possible? Yeah. For every 2 people, 1 edge. For every 2 people, 1 edge. 4 people, so 8 people, 4 edges are over. If I want to cover one more edge if I want to keep, definitely 2 vertices are required. You may say that existing vertices I will use again, then degree become 2. So perfect matching possible only for graph which contain even number of vertices. Odd number of vertices, it is not possible. Fine. So if we can get perfect matching, then no need to check other maximal matching for finding matching. Of course, perfect matching possible, right? I think that will be the answer. Can you help me? Perfect matching possible means how many edges? Perfect matching possible means how many edges? I think half edges. 8 vertices are there, 8 by 2, because for every 2 people, 1 edge. If at all perfect matching is possible, for every 2 people, 1 edge there, I think V vertices, V by 2 edges are there. If at all perfect matching possible, for every problem, I cannot give perfect matching. For every problem, I cannot give perfect matching. If you want, you can check in the above problem. Perfect matching is not possible. In the above problem, perfect matching is not possible. So you cannot go blindly. 8 vertices are there, 8 by 2. 4 is the answer. You cannot say, but I can give guarantee. 8 by 2 is 4. Answer is either 4 or less than 4. Answer less than or equal to 4. I can draw the boundary line. Totally 8 people. I think with 1 edge 2 people, 1 edge 2 people, 1 edge 2 people. So 8 by 2. I think maximum 4 possible. Check maximum 4. 4 means I think perfect matching. Just to verify perfect matching is possible or not. Not possible. So answer going to be 3. Just to check 3 possible or not. 3 possible. So that is the answer. Come here. So 8 by 2, 4. Answer will be less than or equal to 4. Yeah, 4 is belongs to perfect matching. Perfect matching possible. So that will be the answer. Thank you so much for asking. Can we move to next? Right, in the given graph, number, right, is perfect matching possible for a complete graph? That's what I'm saying. How many vertices you have? Are you getting? How many vertices? Perfect matching means every possible edge there. But vertices also matters, na? Can you help? 5 vertices, perfect matching possible. 5 vertices, complete graph only, 5 vertices, perfect matching possible? No. Because, right, one edge, 2 people, one edge, 2 people, like that do 2 times. 4 vertices are over. One more vertex left out. What I will do for that? What I will do for that? Okay? Is it okay? Let's move to one more problem. You will get the idea. See this? How many perfect matchings possible in Kn? See the answer? How many perfect matchings possible in complete graph with n vertices? See the answer. See the answer. Number of perfect matchings possible in Kn is equal to 0 if n is odd. Is it okay? How many perfect matchings possible? How many perfect matchings possible in Kn? Right? Number of perfect matchings possible in Kn is equal to 0 if n is odd. Are you okay with this? Are you okay with this? Yeah, n by 2 should be even because I have to make it 2 parts. Yeah, so Priyosh is saying how? Odd, na? So you only say how possible? You only say 3 people. How possible? Right? So this is the K3. This is the K3. One subgraph you take. Every person degree I want 1. How it is possible? You only say. Is it okay? Priyoshi, is it okay? Number of perfect matching is possible in Kn is equal to 0 if n is odd. It's not possible. Because every person degree 1 I cannot make. Because when you say odd, one person left out. Now see this. See this one. Number of perfect matchings possible in Kn where n is even. Everyone observe. Everyone observe. Very interesting. Very interesting. Everyone observe. Careful. Careful everyone. Number of perfect matchings possible in right. Just I'm giving one example. In K4, how many? I'm calculating. I'm calculating everyone observe. I'm calculating everyone observe. There are 4 people. I'm writing here. K4 means 4 people. Everyone have to observe. Everyone have to observe. There are 4 people. Right? See what I'm doing. Right? Make sure. How many edges you can take? K4 or K6? Yeah, I think to explain little bigger. So let's go for K6. Otherwise, I may not able to explain. I'm taking little bit bigger diagram so that you will get more clarity. K6, let me take K6. K4 you may not get because it will be over immediately. But afterwards you can check the K4 also. Let me try. Yeah. So now see how many edges you will take. K6. K4 means immediately over, only 2 edges. I want to explain, but I cannot do anything. Number of perfect matchings in K6 is equal to 6 people you take. I think 6 by 2, 3. 3 edges I can take. Now observe. Observe everyone. First time I am trying. See this one. First time I am trying. So out of these 6 people, everyone observe. Out of these 6 people, go to any person. Out of these 6 people, go to any person. Any person you go. Okay, any person you go. First stage purpose I am trying. First stage purpose I am trying. Out of these 6 people, go any person. Can you see how many choices he have? A, B, C. It is a complete graph. It is a complete graph, remember. Complete graph means everywhere edge possible. When you say complete graph, everywhere edge possible. Everywhere edge possible. Go to A, right? So with A, you want to take first edge. I am at A now. take the first edge. So A to where I will take? What is the answer? Anyone you take. So I think I have 5 possibilities. Let us assume that out of those 5 possibilities, one of the person I took, 5C1. 5 possibilities are there. Out of 5, select one person. Anyone I am taken, that's fine. Let us assume that the one which I am taken is A already there, A comma B I am taken. So like this I took. I have 5 choices. I took one of them. Now observe. Out of 6 people, 2 people are out. Out of 6 people, already 2 people are out. Can you help me now? Can I take the same person again? Can I take the A again? Out of 6 people, 2 people are out. If you take A again, its degree becomes 2. If I take A again, its degree becomes 2. So A, B, leave. Now go to C. Right? Go to the C, stand at C. Right? I think the second edge purpose I am trying. And so how many choices he have? I am at C now. How many choices he have? Old things he cannot take. A, B already over. I think he have 3 choices. He can go either D or E or F because of it is a complete graph. He have full chance. So I think he have 3 choices. Let us assume he is taken C to D. So now A, B over, C, D also over. 2 edges are over means 4 people are out. Now 2 more people are left out. Out of them go one person. Let us assume that I will go to E, third edge. I will go to E, third edge. So what is the answer now? I think you have only one choice. You have only one choice. Now A, B, C, D, E, F over. All are covered. So now if you see the total number of perfect matchings are 5 into 3 into 1, which is going to be 15. If you want, you can try. 15. So 5 into 3 into 1, 15. Number of perfect matchings in the K6 is equal to 15. Is there anyone who have any doubt? Check. Are Johan, you got or not? Johan, you got or not? Yeah, sir, I joined just now. Okay, maybe. If you are not getting, it's fine. Just to see one time. Right, today maybe he will push because he's merging. I think 2 videos he is making one. He's busy in that. Maybe mostly he will keep it. Yeah, new topic you will get. So I think you got it. Number of perfect matchings in K6 is equal to this one. Because of you are little bit okay. Now can you see the one more story? See this one. See everyone now. Number of perfect matchings possible in K2n. Can you help now? K2n is an even number. Anything you can write 2 into something. Anything you can write 2 into something. Is it even number? If you want, you can write 2k also, no problem. 2k also, no problem. So it is a 2 into n. Number of perfect matchings in K2n is equal to, listen, K2n is equal to, everyone observe. My only intention is it is an even number. 2 into something is there means even number. So if at all here 6 there, take 6. If at all here 10 there, take 10, right? Whatever it is. But one thing, can I write that number as 2 into something? The possibilities here, if you want, you can check. K, what is the answer? 2 into 5, 10. 10 can be written as 2 into 5. One more, K, I think 50, 2 into 25. K, 8, so 2 into 4. Anything which you can write in terms of multiples of 2. So for that only we can find out the number of perfect matchings. So now observe. See everyone, total 2n people. Everyone listen, total 2n people. Out of 2n people, go to one person. Can you say how many edges I can take? I want answer from you. How many edges I can take? How many edges I can take? Totally 2n vertices are there. I think n. Are half na? 2n by 2. If at all previously 6 there by 2, 3. Now 2n by 2. I think n. Whatever is there by 2 you do n. Now let's see this one. Listen, out of those 2n people, I can take out of those 2n vertices to make it as a perfect matching. I can take only n edges. Only n edges. Now see the first choice. Can you help? First one, first edge purpose. First edge purpose. I will go to out of 2n people. I will go to one of the vertex. To him, the other possibilities are 2n minus 1. Remaining all people. 2n minus 1. Out of those 2n vertices, one of the vertex I will go. I will ask him where will you go. So he will say from me, other people anywhere I can go. 2n minus 1. Now after completion of this edge, 2 people are out. Now 2 people are out. Now I have 2n minus 2. In that I will go to one of the person. Second edge purpose, I will go to one of the person. So I will ask him, right? Now I have 2n minus 2. Out of them I went to one person. Now it became 2n minus 3, right? I will ask him, all right, where can you go? So what is the answer? I think the remaining people, 2n minus 3. Every time two people are going out. If you observe clearly, next again 2 people will go out, 2n minus 5, right? So again, if you see this one, 2n minus 7, and so on, it will go. Lastly, don't think much. Lastly, 3 will come. Lastly, 1 will come. So like that will come, right? So if you observe clearly, this answer is going to be number of perfect matchings for K2n. Answer is 2n minus 1 into 2n minus 3. 2 difference, because every time 2 people going out. 2n minus 5 and so on. Lastly, 3. Again, 2 people will go 1. This is the answer for this. This one, if you solve, right? This one, if you solve this one, the answer what you are going to get is 2n factorial by 2n factorial by. Remember this formula: 2 power n into n factorial. Both are similar. 2n factorial by 2 power, right? 2 power n by n factorial. Above 1 and below 1, both are similar. Both are similar. Yeah. Now I'm giving one small thing, right? Listen that also. One small thing I am giving, just listen that also. Listen that also. Can you see this? 2n into 2n minus 2 into 2n minus 4 into 2n minus 6 into and so on. Right? And so on. All the people. Maybe lastly 2 there. You may say that how lastly 2 sir? How lastly 2 sir? What is the answer? It is a 1. Before the 2 only. So if you observe clearly, it is something like almost like odd number. It is almost like even numbers. Can you help, right? Observe clearly, everyone. Everyone observe. This can be written as 2 into n minus 0. This can be written as 2 into n minus 1. This can be written as 2 into n minus 2. And so on. Lastly, if you see, this can be written as 2 into n minus of n minus 1. I think n cancel, 1 will be there. N minus of n minus 1. Right? N minus, space is not there, I am writing again. Don't think much. Here nothing there. Lastly, 2 into n minus of n minus 1. Right? Now, can you observe 0 to n minus 1? How many people? 0 to n minus 1. How many people? Check properly. 0 to n minus 1. How many people? Here 0, here 1, here 2, here 3, n minus 1. 0 to n minus 1 means, right? Definitely n people. So everywhere 2 there. 2 multiplied. I think it became almost like 2 power n times. It became 2 power n. 2 into 2 into 2 into 2 into n times 2 power n. It became 2 power n. Remaining all the people, if you observe, right? These are all multiplied because of multiplication. A, right? If you see the multiplication, all are multiplications only. There is no plus here. Remaining numbers all, if you see, n into n minus 1 into n minus 2 into and so on, right? It became 1. It became n factorial. 2n into n factorial. 2n into n factorial. Are you okay with this? Only for even people. Only for even people. Only for even people. Now I want answer from you. I want answer from you. Above contain even people or odd people? In this formula, above contain even people or odd people? Array above, yaar, above, here. Here you have even people or odd people? All people. You have all by odd. Sorry, all by even. You will get the odd. This is the odd. This is the odd. All odd people came. This is all by even. So it became odd. Like that formula came. Formula came like this. Some people are asking, sir, how can you say above all, sir? You can see this. 2n minus 1, 2n minus 2, 2n minus 3. All are there. All. See, if you want, you can check. These are even people. These are even people. These are even people. If you see this one, these are odd people. These are odd people. So even odd, both are there. Even odd, both. By, right? Only even. Then you will get odd. That's how that formula came. Are you comfortable? Once previous slide, please. Okay. Check. Can I move? Yeah. Someone is saying that 2 into n minus half n minus 1. Yeah, we'll see that. We'll see that also. Can I go ahead? Yeah. So now see this. Can you see this? Those people who are not getting, can you see one time? Can you see one more time? Oh, it is a mathematics, nothing. Right? If I don't explain also, no problem. You can easily handle. Can you see this? Can you see this one? All even people I written. Array, I want answer from you. Abhi, you please give answer. Out of 2n people, how many even, how many odd? Out of 2n people, how many even, how many odd? N people. Total is 2n. Total 2n. In the 2n people, n even and odd, what is there in that? See, it is the 2n. It is the 2n. Next one, 2n minus 2. I think if you common 2, here, it became 2 into n minus 1. 2n minus 4. If you common 2 into n minus 2. But remember, total should be n people. So it is the 0, it is the 1, it is the 2, it is the 3, and so on. Last should be n minus 1. 0 to n minus 1 means n people. So lastly, n cancel 2 into 1 there, which is 2. 2 into 1, which is 2. Now if you observe, after making some 2 everywhere, for every person 2 into there. So I think almost like 2 should be multiplied almost like n time. So 2 power n. Right? Remaining all the people, if you see, n into n minus 1 into n minus 2 into n so on 1, which is n factorial. So 2n into n factorial, which is the even people, even story. Right? Total story by even story you do, you will get the odd story, which is this. So this is the formula. If you can remember, finally this formula, it's more than enough. No requirement of that much discussion. It is very easy. So I done the derivation also. It is a very easy. I done the derivation also. But in the exam, who bother about this one? If at all this formula there, you can use it. 1 or 2 places, right? Every time, see in the examination, this much derivation, wasting time. If possibility there, remember. If possibility there, remember. Possibility there, every time, no need to see. Everyone can do derivation. But exam is not the place where you will do derivation. Meaningfully study. So meaningful things are important. Any numerical problem given, this formula need not be important. You can do like this. See, K6 contain. Remember, this is only for complete graph. Normal graph you have to check manually. Only for nice graph, nice formulas are available. For normal graph, what formula I can give? Edge may be there, may not be there. How many? See the problem? How many perfect matchings possible in Kn? How many perfect matchings possible in Kn? So if at all odd number not possible, even number possible, then how to find out for K6? I tried. In the K6 means 6 by 2, 3. Only 3 edges I can take. So for the first edge, out of 6 people go to 1 person, right? For the first edge, that 1 person can take from 5 people. So 5. 5. Next one. Can you help me now? Interesting answer. These all are going on. Everyone say, these all are going on. I want answer from you. These are individual works or continuous work? These are all people, individual work or continuous work? These all are individual work or continuous work? Continuous, because see this one, you done this. Listen, after if you say individual, after completion of this, you will stop. That is the meaning of this. When you say continuous, fix this first. Further you go. If you stop, that is called individual. If you say after fixing I will go, this is called as product rule. You have to multiply. Still story going on. You are in the middle of the story. You have to multiply. If different story, that story different, this story different, you can add. So it's very difficult to find out which place you have to add, which place you have to multiply. Should I do summation? Should I do product? You have to check carefully. Right? Oh, am I doing right? They are both are individual. There is no relation. Means that work is over. If that work is over, summation. So you are still in the middle. See, only one edge I taken out of 3 edges. Only one edge I taken. What about remaining? If remaining also over, then my work is over. Then you have to do product. But be careful. Don't go blindly. When you practice few problem, automatically you will get the clarity. Right? There is no fixed rule like that. You have to multiply here. You have to add here. Check what is going on. See, no one asked me also, why you multiplied? Because you have sense. Common sense is there. So some people are asking one interesting question. Sir, first time 5 possibilities are there. You taken only 1 possibility. What about remaining? I shown 1 diagram here. Can you say total how many diagrams possible? 15 or not? I shown 1 diagram. If you take some other way, right, totally 15 diagrams possible. See this one. Fix this one. Out of those 5, 1 person fix. I fixed. Remaining how many? 3 possibilities. Some people are asking, sir, how remaining 3 are? Can you see one time? Out of, right, first one is 5 possibilities. Fix this. Remaining 3 possibilities. I think 1 possibility is like this. 1 possibility like this. See the one more possibility. One more possibility may be like this. Right? There is 1 more possibility. But remember, first one fixed. Right? One more possibility is like this. One more possibility like this one. This is fixed only. One more maybe like this. This is also one more. So by fixing this person, I have 3 possibility. In the similar way, see this one. By fixing this person, I have 3 possibility. Similar way, this person can be done another way. This person can be done like this also. So this one I may take like this. Again 3 more will come. Again 3 more. Whatever way I done till now, similar way. I may do one more thing like this. I think we have 5 possibilities. Like this I will take. Remaining again 3 possibilities. So like that, 5 times 3. Every time 3 coming, like that 5 times. 5 into 3, 15. So like that it becomes. That is called product rule. Little doubt also there. Please go it. Just deeply little bit go. Whenever doubt is coming, please don't escape. Whenever doubt is coming, don't doubt yourself. Whenever doubt is coming, don't think that you are incapable. Go little deep, yeah. Little more. Can't you work? Can't you work? This is a place where the ranks will be decided. Oh, little confusing. You will stop it. Then you are not a ranker. Little confusing. Are you going little more deep? Are you finding the actual problem? Then you are going to be the winner. Those are the winner qualities. Every time doubt is coming, stopping. Right? Instead of going little more deep, you are stopping. Then how you become a topper? This much competitive world. If you want to be a topper, you should do some good work also. Yeah, perfect. Let me remove this. So no need to be afraid. Nothing to lose. Nothing. Everything is gain only. In life, you don't lose anything. Everything is gain. Everything is gain only, right? If you think that it is good, go ahead. Yeah, can I move to next? Remember, right? Remember, number of perfect matchings possible in Kn. Kn. Someone is saying that, sir, all total, how many ways we can draw? 15, na? 5 into 3, 15, right? This is the formula. So whatever way, listen, whatever way I multiplied here. See, whatever way I multiplied here. Odd number solve. Same thing I multiplied. Odd number solve. Right? But how to get, right? This formula, if I solve, what I will get? Smallest formula is like this. How to get smallest formula like this? Just I done some small derivation. Just I done some small derivation. Fine. It's really not required. How you derived, who cares? After exam is over, everyone can derive. Who you derive in the exam. Yeah. Can I move to next? Bhaiya, can I move to next? Check. Anyway, sir, I have doubts, sir. Is it product rule or some rule? I seen in your group also, you are asking the aptitude teacher, right? Sir, I am in doubt where I have to do summation rule, where I have to do, right, multiplication rule. Just check yourself. You are not a kid. You are not a kid. Just you also check. Maybe she thought that you know, so she ran away. Right? Can we move to next? It will come in the permutations, combinations. Again, some more examples I will take. Permutations, combination, next chapter is that only, I think so. Right there, I will take some more examples. Right, in the aptitude also some came. I also will take few more. You also learn a few more by seeing previous paper. 1 or 2 places you stuck. Right, so those problems also we will solve. Can we move to next? Number of perfect matchings also I done. Yeah, I hope everything is fine. Now come to the next one. Yeah, this one I think everyone can follow. Happily, everyone can follow next week. Little doubt also there. You can ask your friends, right? So many people will help you. Our group contains so many intellectuals, so many talented people, so many talented. Dust is not there. In the EPT basic, lot of dust there. I don't want to type also there. Someone is saying forcefully, good morning, Reddy sir. So I don't want to say good morning also. Lot of dust there, right? In the dust, if you play, you will get the dust only. Right? So in the EPT prime, there are lot of quality there. Right? So please utilize, post the doubts. Right? Start the next one. Next story is going to be independent set. Right up. Part of the graph only, just write the name as independent set. Independent set. Can we move? Where is the Ashwini? Where is the Ashwini? Ashwini there? No? No? Neha, are you there? Neha there? Fine, perfect. Yeah, so this is the independent set, no relation. It is also graph theory only, right? Everyone follow. No relation with the right? No relation with the previous things. Everyone comfortably can follow. Independent set. Independent set. Take the one graph. Take one graph now. I'm giving one graph. Independent set. Take the one graph. V1, V2, V3, V4, V5. Just concentrate this only. Don't concentrate other than this. Don't concentrate other than this. Only names and some examples are enough. Topic is independent set. Topic is independent set. Yeah, it's a graph only. Topic is independent set. It is a graph only. Now I will ask one thing. Everyone listen. Now I will ask one thing. As name saying, independent set. Can you help me now? As name is saying, independent set. Is it set? Result is set. I took one graph, okay. I took one graph. I'm very happy. I took one graph. But as name saying, independent set. Is it set? Say yaar. Say properly. As name saying, independent set. So remember, output is going to be one set. Input is a graph. Input is a graph. Output is a one set. Independent set is a one set. And one more thing, some people are asking, set okay, sir. Is it set of vertices? Is it set of vertices or set of edges? Set of vertices. Remember everyone. Independent set. I'm writing here. Independent set is a set of vertices. Set of vertices. Independent set is a set of vertices which are not adjacent. Which are not adjacent is known as is known as independent set. I will give example. This is the definition. You may not get it. I will give the answer. Independent set is a set, but set of vertices or edges. Vertices. Independent set is a set of vertices which are not adjacent. Is known as independent set. Set of vertices which are not adjacent is known as independent set. I still remember when I am preparing for the GATE examination, I by hearted like this one. Right? Independent set is a set of vertices which are not adjacent is known as independent set. Set of vertices which are not adjacent is known as independent set. I still remember. One day my friend asked me. One day my friend is asked me. So Reddy sir, sorry, not Reddy sir. So my friend, classmate. How Reddy sir? How Reddy sir? Right? My classmate asked. Right? Yeah, my name is right. As yeah, bro. Yeah, bro is correct. Bro is correct. Hey Subbu. He call you Hey Subbu. Just mind your language. Are Gootle? Hey Subbu, mind your language. Yeah, okay, fine. Let's go for A Subbu only. Yeah. Subbu, what is the definition for the independent set? Independent set is set of vertices which are not adjacent is known as independent set. Let's see the example. Let's see the example. Everyone listen. See the example one. First example. First example. Independent set 1 is equal to independent set 1 is equal to careful everyone. Careful everyone. Is V1 V3 adjacent? Is V1 V3 adjacent? Set of vertices which are not adjacent. Of course, this is one independent set. This is one independent set. V1 V3 is an independent set. These two people are not adjacent. These two people are not adjacent. Fine. Yeah, so, right. One independent set I written. One independent set I written. Can you write one more? Write one more. Independent set 2. Independent. What about V3, V4? V3 somewhere, V4 somewhere. It is also independent set. It is also independent set. What about V1, V3, V5? V1, V3, V5. V1, V3, V5. Is it independent set? Yeah, no one is related. No one is between two people edge there. Then I can say they are adjacent. Between two people edge there. Then I can say these two are adjacent. V1, V3, no edge there. V3, V5, no edge there. So that is also independent set. Next, anything else? So independent set 4. V3, V5. Is it independent set? V3, V5. Yes. Fine. Are you comfortable till now? Yeah. Can you write anything of your choice? Anything, any other thing which is not there? Someone is saying V1, V5. V1, V5, of course. So like that you written. Okay, fine. I'm okay. Now come to the next one. Everyone listen. Come to the next one. Everyone listen. In the independent set 1, can I add one more vertex? Still it is independent set. Can I add one more? Can I add one more without violating the independent set property? In the independent set 1, V1, V3 already there. V1, V3 already there. Can I add one more without violating the independent set property? Can I add one more? V1, V3. I think V5 also I can add. That is the reason. It is the independent set. It is not maximal independent set. It is not maximal independent set. I can add still few more. I can add still few more. Still independent set property hold good. So I cannot add one more. Right, next one. Can you say V3, V5 in the independent set 4, V3, V5? Can I add one more without violating the independent set property? I think I can add V1, right? V3, V5. I can add V1. Still, it is an independent set. It is also not maximal independent set. Next one. Can you go to the independent set 2? Can you go to the independent set 2? V3, V4 already there. V3, V4 already there. Can I add one more without violating the independent set property? In the independent set 2, V3, V4 already there. Can I add one more without violating the independent set property? Is it possible? In the independent set 2, someone is saying V5. Someone is saying V5. Can I add V5 in the independent set 2? If I write V5, V4, V5 adjacent. No, I cannot. Someone is saying V1. If I add V1, V4, V1 become adjacent. So I think to this one, I cannot add one more. Not able to add one more. Right? So that is the reason. That is the reason. The maximal independent set. It is the maximal independent set. Next one. Can you help me? In this, can I add one more without violating the independent set property? Without violating independent set property, not able to add one more vertex. Then it is called maximal independent set. Here, can I add one more? I think already more people are there. If you add one more, it's a really serious problem. Same story. It is also maximal independent set. Without violating independent set property, not able to add one more vertex. It is also maximum. Can you go to independent set 5, V1, V5? I think you can add V3. So it is not a maximum. Fine. Are you okay? Are you okay till now? Are you okay till now? Now listen. Now listen. How many maximal independent sets you have as of now? How many maximal independent sets as of now you have? I think 2. Is there anything else? If you want, you can calculate. Can you find out one more maximal independent set? If you want, you can try. Try. Anything else? Set of vertices which are not adjacent is known as independent set. Without violating independent set property, not able to add one more vertex, then maximal independent set. We have 2 maximal independent sets as of now. This is the maximal one. This is also maximal one. Yeah, first one contain 2 people. Second one contain 3 people. Right? So these 2 are maximal independent set. First one contain 2 vertices. Second one contain 3 vertices. Remember, it is a maximal independent set which contain more vertices. This is called as independent set number. Independent set number of the graph. Like matching number of the graph, independent set number of the graph. They will ask you in the exam. You have to say answer for this one is 3. If anyone say 4 possible, please let me know. In all maximal independent set, whichever having more vertices, that is the independent set number of the graph. In all maximal independent set, whichever having more vertices, that is the independent set number of the graph. Answer is 3. Independent set number of the graph is 3. Find out maximal independent sets first. Among all of them, whichever having more vertices. How many? 3. That is called independent set number of the graph. Check anyone having any doubt? Yeah, I think see, Jaya asking something. Sir, only vertex 2 is the maximum. What is the vertex 2? What is the vertex 2 is maximal? What is the meaning? See, you cannot add one more vertex. It is also maximal. You cannot add one more. It is also maximal independent set. It is also maximal independent set. Out of them, whichever one contains more vertices? That is called independent set number of the graph. Independent set number of the graph is 3, means among the maximal independent set, whichever having more vertices. What is the number? 3. So independent set number of the graph is 3. Like matching number of the graph above problems, here independent set number of the graph. I hope you got. Someone is saying that only V2. See, I think JI is asking one interesting thing. Sir, only vertex 2 is maximal. Can you help me now? Only vertex 2, is it maximal? I can add one. I can add one more. Oh. Can I add one more? Only V2 if I take, can I add one more? Only V2 if I take, can I add one more? You cannot add, right? You cannot add. So yeah, I will write that also because it is an interesting point. I will write that also. Independent set 6 is equal to only V2. See, whatever you written, no two people are adjacent. So in the independent set 6, no one is no one is adjacent. It is also independent set. It is a maximal also. But it's having only one vertex. But I want maximum, so independent set number of the graph is 3. Thank you so much for informing that. Thank you so much for informing that. Fine. Can we move next? Sir, for complete graph, is number is always. So for complete graph, I think one vertex only you can take or not. For complete graph, only one vertex you can take or not, because everyone is adjacent. For a complete graph, everyone is adjacent. You cannot take one more person. Right? So I think that whatever you are saying, hidden, you are correct. So can we move next? You got clarity. Can we move next? In all maximal independent set, which one having more vertices? That is called independent set number of the graph. Please careful. Okay, fine. You are okay. So in one of your previous paper, this question is given. Try yourself. In one of your previous paper, this question is given. You can try this. You can try this. The question what is given. So I will read once. Yeah. What is the size of smallest, sorry, what is the size of largest maximal independent set of a chain of 9 nodes? What is the size of largest? So first of all, find out maximal independent set. Maximal independent set of a chain of 9 nodes. Right? In that, right? So you may be get many, you may be get many in that largest. But he's asking size. Means the number of vertices. What is the size of that? Indirectly, directly they are asking maximal independent set. Indirectly, directly they are asking independent number of the graph. Independent set number of the graph they are asking. But graph is given, very nice graph, chain of 9 nodes. Chain of 9 nodes. I think if anyone is not getting graph, you can take the graph. This is the graph what they are giving. Chain of 9 nodes. Like this. 4 already over. 5, 6, 7, 8, 9. A, B, C, D, E, F, G, H, I. Maximal. Try for maximal. Try for maximal. No need to try all. It is a time waste. No need to try all. It is a time waste. See, wrong also no problem. Everything is learning. Don't worry about I may do wrong. I never seen a person who grown without doing wrong. I never seen a person who grown without doing wrong. If you keep on afraid, I may do wrong, I may do wrong. Arey, who is God here? Who is not done wrong? Who is not done wrong? Yeah. So Modi ji said in the right first time when he is winning, first time when he is participating in the election as a prime minister, in every one account I will keep 15 lakh. Modi ji said that in every one's account I will keep 15 lakh. He said like this. Right? He is not kept in anyone's account. I keep on verified. As soon as he became prime minister, every day I used to check when it will come, when it will come, when it will come. Every day I used to check. Because he promised, the prime minister is promised in every one account, right? We will keep 15 lakh. So as soon as the results came, I used to check again and again, every day. 15 lakhs not coming. Oh, I got to know. Okay. Without doing mistake. So afterwards, maybe he didn't play any mistake. I don't know. I'm not that much right concentrated. But that is the mistake what he done. If you don't say also, he will win. If he don't say also, that time he will win. Unnecessarily he said. So you want to say that sometimes it will happen. So if anyone thinking that's my answer may be wrong, it's okay. It's okay. Can you try your attempt? What is the size of largest maximal independent set of a given of a chain of right for 9 nodes? So I think one independent set is I cannot write all. I am writing the major one. I think alternative you can write A, C, next one E, G, and I. So, and one more thing is, it is a one independent set, okay. But if I add one more person, it is no more independent set. It is a maximal also. It is a maximal also. Maximal independent set. Okay, that is fine. Is there anything else? I think one more if you identify, instead of writing the corner things first two, maybe you can do like this also. Right? You can do like this also, maybe. This one, you can do like this also. See this one? I'm thinking like this. Any change in the answer, let me try. Any change in the answer, let me try. If I take this B, 2 people are covered. If I take this B, 2 people are covered. If I take this E, 2 people covered. If I take this H, 2 people covered. So let me write my opinion. B I will take. I will take B. I will take B. I will take E. I will take H. Can you see, is it independent set? Yes. Is it maximal independent set? Can I add anyone? Can I add anyone? So it is also maximal independent set. You cannot add one more. So can you help me now? Answer for this one is asking largest maximal independent set of a chain of 9 nodes. I think what is the answer? 5. 5 is going to be independent set number of the graph. Am I right? Is it okay? Is it okay? Is it fine, Bhaiya? What is the size of largest maximal independent set of a chain of 9 nodes? So maximal is 5 I got. Now listen. This question is given in one of your previous paper. Listen, this question is given. Someone is saying that BDFH also. Let's check. I will write that also. 1 gap. 1 gap. Fine. Yeah, this is the maximal one. Remaining may be right. Now listen. I changed the problem. Remember, in that exam they are asking what is the size of maximal independent set of a chain of 9 nodes. In the place of largest, they given smallest. What is the answer? What is the size of smallest maximal independent set of a chain of 9 nodes? What is the answer? In the exam they given smallest. Right? Largest means independent number of the graph. Instead of that, is given smallest. What is the answer? I think 3. There is some nice game is there. So this is the smallest. In all maximal independent sets, this is also maximum. Largest one is called as largest maximal independent set. That is okay. Which is also called as, right? If you see the how many 5, that is independent set number of the graph. Right? This is the smallest maximal independent set. In the similar way, can you go to previous problem? Previous problem. What is the smallest one? In all the maximal independent set, largest one is going to be, I think, independent set 3. Number is 3. That is perfect. Can you help me? What is the smallest one? Is it smallest one? It is the maximal independent set. Which is the smallest? Smallest maximal independent set. Write this also. It will be useful, so please write it. Yeah, okay. So largest is IS3, of course. Right? In all the maximal independent set, which contain more vertices, I think 3. So independent set 3 is the largest one. Right? We written already. We already written, right? So independent set number of the graph means the largest one only. It is the largest independent set, which is also called as independent set number of the graph. If they ask you smallest, then go for smallest. Okay, fine, perfect. Any doubts? Any doubts here till now? Till now, any doubts? Knowing the definition, some examples. Knowing definitions, some example. Clarifying doubts. Clarifying doubts. Nothing there. Nothing. Don't do research. Don't do by hearting. Don't do research. Don't do by hearting. Yeah. Can I move? Can I move now? We done very decent work. Decent work we done. Can we move next? Previous slides, please. Yeah. Check. Anyone having any doubt? Yeah. Neha, can I move to the next? Fine. Perfect. So I'm giving one problem which is very tricky. So let's try how many people will do. It's very tricky. See how many people will do. Write down this. Let G be a simple graph. How many people will do? Let's see. Let G be a simple graph with n nodes. With n nodes and k components. If a vertex if one of the vertex of G is removed. If one of the vertex of G is removed, then the number of components present in resultant graph maximum and minimum, or minimum and maximum, whatever it is, minimum and maximum. You have to find out. Option A, K and N. B, K minus 1 and K plus 1. Option C, K minus 1 and N minus 1. Option D, K plus 1 and N minus K. This is the problem. So if anyone having any doubt, please let me know. See, I have a graph which contains k components already. That graph contains n vertices and k components are already there. If I remove one of the vertex from the G, in the resultant graph, minimum how many components can be, maximum how many components can be. Please try. It's very interesting. Take example and check. Mostly you will get the clarity. Take example. Take example. Most of the things you can do with the help of example. You know all the basics. What is component? You know. What is graph? You know. What is vertex? You know. Right? Can you try a little bit? Can I help now? K components. What is the K minimum value? K components. What is the K minimum value? One also minimum, ma'am. Right? Let G be a simple graph with n nodes and K components. K can be anything. K may be 1 also. K may be 2 also. If one of the vertex of G is removed from the given graph, G is right. If one of the vertex of G is removed, then the number of components present in the resultant graph is minimum how many, maximum how many. Yeah, I will try. I will try once. Listen, I will try once. Careful everyone. I will try once, you may get clarity. See this. It is a graph. Everyone listen. It is a graph. Can you help now? This graph contain how many vertices? This graph contain how many vertices, how many edges? Vertices are, I think, 4 plus 3, 7. 7 plus 2, 9 plus 1, 10 vertices. Edges, if you see, 4 plus 3, 7 plus 1, 8. And components, how many? This graph contain how many components? This graph contain how many components? K value 4. K value 4. Now see what happened. If you delete one of the vertex, I want answer from you. If you delete one of the vertex, can you help me now? Number of components can decrease minimum by 1 or not? Number of components will decrease minimum by 1. You cannot delete 2 people because one vertex only deleted. One vertex only delete. Can you help me now? Sometimes number of components may not decrease also. You deleted one vertex, so still number of components are not decreased. See this one, you delete this. You delete one vertex. Resultant graph, if you see this one, you deleted one vertex. See this one, you deleted this vertex. Whenever vertex will go, their edges also will go. So sometimes what happened is, from the given K components, if you delete one of the vertex, so still K components as it is. Can you help me now? Sometimes as it is or not. From the k components, if I delete one vertex, sometimes k components as it is or not? As it is, sometimes as it is. Right? Sometimes as it is, if you are little lucky, sometimes one will decrease. Right? Minimum thing what can happen is this will go. Components will become one less. There is no chance of two less. Can anyone show to me two less? Can you show to me two less? If I delete one vertex, how two will go here? If I delete one vertex, how two components will go? If I am lucky, nothing will change. If I am unlucky, one may change, one may decrease. So minimum is k minus 1. Minimum k minus 1. Minimum k minus 1. He is saying that minimum is k. No, one will decrease sometime. Sometimes one will decrease. He is saying minimum. So this cannot be the answer. Fine. So answer is, he is saying minimum is k plus 1. Minimum is k plus 1. He is saying minimum is k plus 1. Array buffoon. Array bekar. Minimum how k plus 1? This bekar is saying that minimum k plus 1. So if you are lucky, it may not change also. So k is okay. But he's saying k plus 1. No. Are you comfortable till now? A graph which contains k components, if I delete one vertex, right? So previously k components, now also can be k or sometimes one less. Sometimes one less. Minimum got the clarity. Can you see the maximum? Very interesting. Can you see the maximum? Let us assume. Everyone listen. Let us assume here. K can be 1 also, right? So let's see the worst incident. What can happen? Everyone observe. Let's see the worst incident, what can happen. Totally, I have n vertices. N vertices are like this. And one component. With n vertices, I have one component. If I delete one vertex, I deleted this vertex. Then can you help me now? How many components? I deleted one vertex only. Whenever vertex going, their edges also will go. Out of n people, one person I deleted. Right? Remaining n minus 1 people, everyone became a component. Am I right or not? Bhaiya, am I right or not? If I delete one vertex, so that vertex gone, their edges also gone. Remaining all became one component. So I think maximum n minus 1 component. Will you agree? If you delete one vertex, remaining all vertices, it can become one component. Let us assume the graph is a star graph. Middle person you deleted. So one vertex gone. Remaining n minus 1 people, everyone become a one component. So I think maximum is n minus 1. Will you agree? Maximum n minus 1. Will you agree? Maximum n minus 1. Will you agree? Maximum. So I think what is the answer? This one and this one. So it's a k plus 1 maximum. Correct, bekar. This is nice. So that's what I'm saying. Can you help me now? Minimum, maximum. Can you help me now? In between also possible or not? In between also possible or not? When I say this is the minimum, this is the maximum, in between also possible. In between also possible. Sir, k minus 1 min. Then k na from minimum also. Write properly. See, one small question. Again, I'm asking you. I have k component. If I delete one vertex, minimum what can happen? I have k components. If I delete one vertex, minimum how many components can decrease? I give an answer. One will decrease. I have k component. I deleted one vertex. If I am lucky, nothing will change. If I am lucky, nothing will change. If I am unlucky, one will decrease. How many will increase? I think increment can be done like this. Increment is the nice thing here. The important point is their increment. One person, if you delete, there may be a chance that so many will come. See, these all will go. These all will go. N minus 1 will come. Sir, one minimum is k minus 1. So that's what I'm saying. See the range. Range will be k to n minus 1 or not? K to n minus 1 means, see this. K minus 1 to n minus 1 means it can be in between k also possible, k plus 1 also possible, k plus 2 also possible, and so on, n minus 2. They are also there. This is the minimum. This is the maximum. You cannot show to me less than k minus 1. You cannot show to me more than n minus 1. Are you getting? You see, my answer is wrong. Everyone listen. My answer is wrong if you can show less than k minus 1. My answer is wrong if you can show more than n minus 1. POC in between also possible. What he is saying, minimum what, maximum what? You have to say range. You have to say range. Range you have to say. Range you have to say. Minimum what you say, maximum what. In between many there. I cannot say all. That's what he's saying. Minimum what you can expect, maximum what you can expect. I said minimum k minus 1. My answer wrong if you show k minus 2. My answer wrong if you show k minus 3. Right? You are saying k. You are saying that is not a minimum, right? The less than that also possible. So minimum k minus 1, maximum n minus 1, in between also possible, depending upon graph. Fine. Are you happy with this? Small tricks. See, small tricks. Small tricks. Small tricks. You have to imagine the diagram. Oh, I want maximum. I want maximum. Right. Do practice whatever way you like before. Don't try directly POC. Right? Try before. That's the reason I used to say write the tests. Right? Let me write now. One more problem. Right? Take this also. If G is a simple graph, if G is a simple graph with n vertices and k components, then G can have at most edges. Fine. then G can have at most edges, means maximum how many edges. Then G can have maximum how many edges. Then find maximum edges present in G. Let's see how many people will. Try whatever you are thinking. Yeah, write in terms of Abhi, can you write in terms of K? So you are not considered K at all. K components are there. It should work for any person. Any K value it should work. Yours will work only for K is 1. K components are there. Someone is saying lagging. Yeah, I made 5G. Now it's fine. Now it's fine. It is a nice problem. Can you try this? Yeah. Can I give answer? Can I give answer? Yeah. Let's see. Everyone listen. It's a nice problem. Everyone listen. It is a nice problem. K components. Let's take any K value. Need not be K as 1. Take any K value. Any K value you take. See this one. Any K value you take. K value 4. Careful. K value 4. N is equal to, observe, N is equal to 10. 10 vertices are there and 4 components. Listen, interesting answer, right? Interesting answer. 10 vertices are there and K components. But one thing I want to ask you, a graph contain more vertices, a graph contain less vertices. Who have more edges? A graph contain more vertices, a graph contain less vertices. Which have more edges? Graph contain more vertices, graph contain less vertices. Which one having more edges? More vertices. Right? You want more edges, more vertices, more edges. Remember, more vertices, more edges. So you want more vertices. Now see the answer. Now see the answer. One component contain one element. One component contain one node. One more component contain one more node. One more component contain one more node. So that next one contain more. Next one contain remaining all. How many? I think out of 10 people, 3 people are out, 7 people here. With the 7 people, the maximum number of edges possible is 7 into 6 by 2. Outside no edge there. This entire thing is one graph. Try to make sure in one of the component more vertices are there. You want 4 components? Okay. Component 1, 1 person only. Component 2, 1 person only. Component 3, because you want 4. Right? 3 components, 3 vertices. I want to make sure in the one component, right, in one graph or one component, more vertices, so that more edges will come. So I think 7 vertices. It's the case 7. Case 7. Complete graph with 7 vertices. 7 into 6 by 2. Now I think some people are asking, sir, how you got this number 7, sir? What is the answer? From the total 10, remove outside 3 people. From the total 10, remove outside 3 people. Outside 3 people remove. Then you got 7. Then you got 7. Can you help me now? So 3 means, can I write in terms of k? I think it is n minus k minus 1. Can I write? N value 10, k value 4, 4 minus 1, 3, 10 minus 3, 7. Am I right? Is it fine? Will you agree? Will you agree? No. Can you help me now? Will it work for? Let's check that also. Will it work for k value 1? Will it work for k value 1? Check. K value 1 means n into n minus 1 by 2. K value 1 means n into n minus 1 by 2. Will it work? If you keep k value 1, 1 minus 1 becomes 0, totally becomes n. N vertices n into n minus 1 by 2 edges are there. Will it work or not? It will work every time. Right? Yeah, fine. Yeah, is it fine now? Sorry for inconvenience. Someone is going from out of house. Just I said send off. So is it working? Is it working for every graph? So the number of vertices, listen, the number of vertices present, the number of vertices present here is n minus k minus 1, because k minus 1 people are outside, right? So with n minus k minus 1 people, how many edges possible? Right? A into a minus 1, complete graph. A into a minus 1 by 2. What is the a? N minus k minus 1 into n minus 1. N minus k minus 1, whatever you have, minus 1 again by 2. If you simplify, it is a minus, right? Minus k plus 1, minus k plus 1, minus 1, both are cancelled, it become n minus k, right? It became so some other number. So it became n minus k into n minus k by 2. Is it okay? This is the formula for this. If you by heart, no use. If you by heart, no use. Some people are asking, sir, why you kept outside 1 1, sir? Can anyone guess? Can anyone guess why we kept 1 1 outside? Can you say the logic? Why we kept 1 1 outside? If I keep outside 1 1, I will get more vertices in the last one or not? Fine. If I keep 1 1 outside, right? Inside, right? This person, last person, this person have more vertices. This person having more vertices, so that I will get the more edges. How many? 10 minus 3. Outside 3 people, 10 minus 3. So 7 people. 7 into 6 by 2. Similar way, how 7 came? N minus, right? 10 minus 1. Sorry, n is 10. N minus 4 minus 1. Like that 7 came. Same story items. Fine. Are you, Bhaiya, are you comfortable? Bhaiya, are you comfortable? Very confusing, yeah. After half an hour explaining it. Very confusing, yeah. You want more edges. You have k components, you want more edges. So what you do is, in every component keep less people. Then one component having more people, then more edges will come. So totally 4 components. One component I will kept outside one node. One more component I kept outside one more node. One more component I kept outside one more. So totally 3 nodes only over. Remaining 7. Contain in one more component. 7 people, more edges I want. 7 into 6 by 2. So same thing you do in terms of n and k. What is that 7? Can you help me in terms of n and k? What is that 7 say? I want answer. In terms of n and k, can you say what is that 7? Say the answer. How 7 came? Total vertices how many? Are Gootle? Total 10 vertices. Outside 3 people, 1 component. 10 minus 3 is 7. Vertex 1 here. Vertex 2 here. Vertex 3 here. So remaining vertices how many? 7 vertices. Vertex 4 to vertex 10 here. Why you kept in one component? The component number 4. Component 1, component 2, component 3, component 4. Component 4 contain more vertices, so that I will get more edges. How many vertices are there in the last component? Means component 4, 7 people. How 7 came? From the 10, outside 3 people remove. So in terms of k, what is that 3? Right? So 10 minus k minus 1. 10 means n. N minus k minus 1. Now, so with the 7 people, how many edges? 7 into 6 by 2, similar way. These many vertices, how many edges possible? N minus k minus 1 into n minus k minus 1 minus 1 by 2. Suppose if it is a into a minus 1 by 2, what is there in that? This is a assume. With the a vertices, how many edges possible? A into a minus 1 by 2. So I think if you see the formula, I think minus 1 plus 1 cancel, check. So this became n minus k into n minus k minus 1 by 2. These are the maximum edges possible. Right. If G is a simple graph with n vertices and k component, then find the maximum edges present in G. If you want maximum edges, remember, if you want maximum edges, you need maximum vertices. But I want 4 components also. So, okay. So in one place, I want more vertices. In other places, less vertices. So one component contain one person. One more component contain one person. One more component contain one person. 3 components are over. Total, I want 4. In the 4th component, remaining vertices you keep. Try to make, if you want more edges, more vertices required. Some people are asking, will it work for k is equal to 1? Only one component. 10 vertices, only one component, more edges possible. Will it work? Check here. Everyone see this. K value 1 is you. If k value 1, if you observe, it is a 1. It is a 1. 1 minus 1 is 0. It became n minus 0 means n into n minus 1 by 2. Working. K value 1, it is working. It will work for anyone. Only one component, still it will work. 2 components, still it will work. This graph contains maximum these many edges. Right. Now one more interesting answer. Because of they are asking maximum edges, this is the story. Can you help me? Minimum edges. If you want minimum edges, listen everyone now. With the k components, if you want minimum edges, what you do is, in a last component more vertices, right? Keep the more edges. Then this formula will come. Last component more vertices. Then keep the more edges. Then maximum edges will come. Last component keep the minimum edges. Last component keep the minimum edges. Because it is you want minimum. Minimum edges means a tree, not complete graph. Then minimum will come. So that minimum is this is the answer. So what is this 7? 7 can be written as n minus k minus 1. So how the 6 can be written? Tree. 6 edges how? Tree means 6 edges. How it came? N minus k minus 1 already. These many vertices are there. Right? From this remove one more one. Minus 1 plus 1 both cancel. So n minus k. So I'm going over, I am writing one small change. Can you see this one? Then find maximum edges present in G and minimum also. Chalo. Yeah, this is the last class. Right, this is the last class. I hope everything is fine. If any doubts are there, please go through it one time. Still doubt is there, you can ask in the group. Come to the today's topic, graph connectivity. Yeah, I hope everything is fine. Graph connectivity. Now take the first example. What exactly graph connectivity? Take one example. A, B, C, D, E. A, B, C, D. Yeah, this is the graph. Right. I hope Gayatri joined. Gayatri, you joined? Yeah, everyone fine. Everyone fine now. Now see this. This is the graph. Observe everyone. This is the graph. Can you help me now? Is it connected graph or a disconnected graph? Go ahead. Is it connected graph or a disconnected graph? Connected graph or disconnected graph? Connected, right? Fine. It is a connected. Can you help me now? This is the connected graph. Okay. In this connected graph, is there any vertex? Is there any vertex? By deleting that vertex, together with its edges, graph become disconnected. In this graph, is there any vertex? By deleting that vertex, together with its edges, graph become disconnected. Anyone like that? I think F. If you delete the F, right? Whenever F will go, F adjacent edges also will go. E will also go. E will also go. Whenever F is going, F adjacent all edges will go. Then I think if you observe clearly, so I think this person is waiting here. These all people are waiting here. I think graph become disconnected. When you delete F together with its edges, graph become disconnected. Remember, this vertex F is called, this vertex F is called cut vertex. Right? This vertex is called cut vertex. Right? Please give. Can you write the definition by your own? Write down. So here cut vertex is F. What is the cut vertex definition? In the given connected graph, by deleting any vertex together with its edges, graph became disconnected. Then that vertex is called cut vertex. In the given connected graph, by deleting any vertex together with its edges, graph became disconnected. Then that vertex is called cut vertex. Please write properly. Only nothing new name will come. The small definition. Please take care. Which is also called articulation point. Exactly. In algorithm terminology, it is called articulation point. Cut vertex is F. Or articulation point is F. Just know the definitions. Right? See the previous paper. Right? Whatever I said in the classroom, plus see the previous paper. Mostly your work done. Plus weekly test. If you do that, it is over. Graph connectivity. In that first one, cut vertex or articulation point. Now in the given graph, listen, in the given graph, F is the articulation point or F is a cut vertex. I am very happy. Can you say what about G? In the given graph, right, F is the articulation point or F is a cut vertex. Then what about G? Can you help now? If you delete G together with its edges, graph became disconnected. If you delete G together with its edges, graph became disconnected. No. If you delete G together with its edges, let's, if you want, you can check. G gone, their edges also gone. Graph became disconnected. No. So no problem. So G is not a articulation point. G is not a articulation point. I hope everyone is fine. Are you comfortable? Are you comfortable? Are you comfortable? Yeah, that is articulation point definition. Now see one more thing. See the one more thing. A, B. See the one more thing. A, B, C, D, E. That's okay. So like this. Now listen. Listen everyone. Can you help me now? In this graph, by deleting any vertex together with its edges, graph become disconnected. Anything like that? In the second example, by deleting any vertex together with its edges, graph became disconnected. Anything like that? Someone is saying by deleting A together with its edges, graph became disconnected. I think A is the articulation point or not? If that is the case, previously here also, I think here also A is articulation point or not? It's exactly. In the previous diagram also A is articulation point or not? Am I right? Previously A is articulation point or not? Yes. I think in the previous diagram, what about B? I don't think so. What about D? I don't think so. What about E? I don't think so. What about C? I don't think so. I think A and F. In the previous diagram, A and F is articulation point. A also, F also. I think see this one. See everyone now. By deleting one person, total system is spoiling. By deleting one person, total system is spoiling. It is not a good idea or not? It is not a good idea or not? By deleting one person, total system is spoiling. I think it is not a good idea or not? That is the reason. See this one. Articulation point is like a project manager. One project is going on, major person is project manager. Unfortunately, project manager is not able to attend. I think total project collapsed or not? Project manager unable to attend. Project manager unable to continue. Total project will collapse or not? Total project will be collapsed or not? Unfortunately, one of the project manager behaving like a articulation point. It is a serious issue. It is a serious issue. So the solution for this one is, I think that is the reason companies what they will do is they will keep the project manager. They will keep one more also, associative project manager. Am I right? They will keep one project manager below associative project manager, and they will give warning also. Management team will give warning also to associative project manager. Remember, at any point of time, main project manager don't come. You are the one who have to take the care. You are the one, right? You have to take the care. Suppose the actual project manager, because of some reason, is unable to come to the team, inside the team. You have to take care. That is the reason every company, every big companies, can I help you now? Every big companies contain something like this one. Senior project manager, right? Assistant project manager, associate project manager. 3 people will be there. 3 people will be there. 3 people will be there, right? For every big project, 3 people are involved, right? Different names will be there, right? In different companies, different name. Senior project manager, assistant project manager, associate project manager. Because backup purpose, right? All 3 people will do almost the same work. But anyhow, come here now. So articulation points, if anything is behaving like articulation point, definitely we have to avoid it. Definitely we have to avoid it. Okay, fine. Cut vertex, I think in this diagram, cut vertex is A also, F also. Now come to this diagram. See this one, come to this diagram. Everyone observe. In the second diagram, if you observe also, okay, some articulation points are there. It's okay. Please listen. Please listen this also. In the second diagram, if you observe, please see this one also. Edge 1, edge 2, edge 3, edge 4, edge 5, edge 6, edge 6, edge 7, edge 8, edge 9. Anything else? Edge 10, edge 11. Now, one small question. In the second diagram, if I delete edge 8, in the second diagram, if I delete 8, right, edge 8, graph become disconnected. In the second diagram, if I delete edge 8, graph become disconnected. In the second diagram, if I delete edge 8, graph become disconnected or not? No. No. But if you see, if I delete edge 11, graph become disconnected. If I delete edge 11, graph become disconnected. Yes. So remember, right? Edge 11 is called cut edge. Right? Is called cut edge. Let me write. Like cut vertex, cut edge. Right? By deleting a particular edge, graph become disconnected. That is called cut edge. I think 11 is a cut edge. Right? Which is also called as, normally in algorithm terminology, which is called bridge. Which is called bridge. So if at a bridge collapsed, you cannot go from right this side to that side. Cut edge, another name is called bridge. Fine. By deleting any edge, graph become disconnected. Then that edge is called cut edge. Now, interesting answer. Cut vertex means you have to delete only vertex and their edges also. Cut vertex means you have to delete vertex and its edges also. See, when you say F is a cut vertex, you have to delete F also. You have to delete the edges also. But remember, cut edge means delete edge only. You cannot delete vertices. You have to delete only edge. So I'm writing now. Delete only edges. Not vertices. Not its vertices. But here, cut vertex. Delete vertex and its edges. Cut vertex, cut edge. Fine. Are you okay? Are you comfortable? Right? See this one. I think if you see in the computer network, right? Everyone knows graph is a computer network. In any computer network, any node is behaving like a right cut vertex. That computer network is not good. It is not reliable. Every graph is a computer network. Right? Every node is a computer. Every node is a router. Right? In the computer network, any router behaving like a cut vertex is not a good idea. Any connection, right, between two computers, there is a one edge, which is called connection. Any edge behaving like a cut edge, then that computer network is not reliable because unfortunately that link is broken. There is no communication from A to F, remember. So these kind of things we have to avoid. Cut vertex, if any router behaving like a cut vertex, we have to avoid it. If any edge behaving like a cut edge, we have to avoid it. I hope you got it. Anyone having any doubt till now? Cut vertex okay, cut edge okay. Anyone having any doubt? Just names only. Please careful. Just names only. Can I move to next one? Right, let's move to next. I think cut vertex, cut edge, I said. Okay, perfect. Cut vertex and cut edge. Now see the next one. vertex. See the next one. Next one also take care. Vertex connectivity. What is the meaning? You will see now. Vertex connectivity. Right? I will explain. First example I will explain. Afterwards we will go to the next one. Vertex connectivity. V1, V2, V3, V4, V5. Just I am arranging one diagram. Yeah, fine. Vertex connectivity. Now observe. Now observe now. Everyone observe. Vertex connectivity. Observe everyone. Vertex connectivity. Observe everyone. Is there any articulation point here? Remember, vertex means vertex. Remember, vertex means vertex. Remember, vertex means vertex. Can you help me now? Is there any vertex which is the articulation point? Clarify this also. Is there any vertex which is articulation point? Is there any vertex which is the articulation point? Anyone? So I think Atul is saying V1. If I delete V1 and their edges, graph become disconnected. No. No. No, Atul. If I delete V1, together their edges, graph became disconnected. No. So V1 will go, their edges also will go. A resultant diagram is right, not disconnected. Can you help me? Any one is the articulation point. In this graph, any one is the articulation point. In this graph, any one is the articulation point. No. Now let me check one small line. Everyone listen. Let me check one small line. Let me check one small line. Everyone listen. S1 is equal to observe properly. S1 is equal to V5. Listen, S1 is equal to V5. When I say V5 I am deleting. See this one. When I am saying V5 I am deleting. Whenever V5 is going, their edges also will go. Whenever V5 is going, their edges also will go. Can you see his graph disconnected? Whenever V5 is going, their edges also will go. Resultant diagram is connected or disconnected? Resultant diagram is connected or disconnected? Still connected. Resultant diagram is still connected. Am I right or not? Now what I will do is V5 by the, I will do V2 also. If I delete V2, right, V2 will go and their adjacent edges also will go. Can you help me now? Now resultant diagram is connected or disconnected? Resultant diagram is connected or disconnected? Still connected. Resultant diagram is still connected. Am I right? Resultant diagram is still connected. Am I right? Right? I hope everyone is comfortable. Now listen. Now listen everyone, because of you are really absolutely fine. You are absolutely fine. Just I want to ask you one small line. Careful. Is there any set of vertices? By deleting them, graph become disconnected. By deleting one person, graph is not disconnected. So there is no articulation point. Whenever no articulation point, to make the graph as disconnected, I have to delete more than one person. Can you say more than one person whom I have to delete so that graph become disconnected. Anyone? Yeah, I will try. I will try this. Can you see this one? I will try. Everyone observe. Everyone observe. I will delete V2. See this one. I will delete V2 together their edges. I will delete V2 together their edges. I will delete V3 together their edges. Can you see graph became disconnected? I deleted V3. I deleted V2. Graph became disconnected or not? Right? Set of vertices by deleting whom graph become disconnected. Set of vertices by deleting whom graph become disconnected. Graph became disconnected. I think by deleting V2 V3 graph became disconnected. Right? By deleting these two people, graph became disconnected. Anything else? Anything else? Any other answer? If at all articulation point is there, one vertex enough. If at all articulation point is there, one vertex enough. If articulation point is not there, more than one you have to delete. Is there anything else? So the graph become disconnected. Please let me know. Is there anything else? Graph become disconnected. Anything else? Someone is saying that V4, V3, V2. Let's check V4. I'm trying this one. V4. Okay. V3. Okay. V4, V3, V2. Right? This is also. Let me write. S2. V3, V4, V2. This also. Set of vertices by deleting whom graph become disconnected. Right? So remember everyone. So this is also by deleting these two people, the graph become disconnected. By deleting this one, graph become disconnected. So minimum vertices are these one. Right? Remember. Vertex connectivity number is nothing but minimum number of vertices I have to delete, so that graph become disconnected. Is known as vertex connectivity number. Minimum number of, I'm writing now. Minimum number of vertices to be deleted. Minimum number of vertices to be deleted. So that graph became disconnected. Is known as vertex connectivity set. Right? Next one. How many vertices you deleted? That number is called as number of vertices. Minimum number of vertices to be deleted, so that graph became disconnected. Is known as vertex connectivity set. That is that number. How many vertices are there? That number is called as vertex connectivity number. See, by deleting these people, graph became disconnected. By deleting this one, graph became disconnected. Right? Remember, this is called as vertex connectivity. This is called as vertex connectivity set. Minimum number of vertices to be deleted so that the graph becomes disconnected is known as vertex connectivity set. Right? That number is called how many people? 2 people. Right? That is going to be vertex connectivity number, which is 2. That set is called as vertex connectivity set. How many people are? That cardinality is called vertex connectivity number. Minimum number of vertices to be deleted so that graph became disconnected is known as vertex connectivity set. That how many people? 2 people. That is called vertex connectivity number. Minimum degree among all vertices is equal to vertex connectivity number. You will get that also, right? Let's go ahead further. Are you okay with the vertex connectivity? Hayden is saying something. It may come in the next slide. It will come in the next slide. Can you help me now? Can you help me now? Everyone listen. Everyone listen. Can you help me? I'm expecting answer. Can you help me? Everyone help me. For this problem, answer is 1. If the graph contains cut vertex. Am I right or wrong? To this problem, answer is 1. If the graph contains cut vertex. To this problem, answer is 1. If the graph contains cut vertex, right? Minimum number of vertices to be deleted. So the graph became disconnected is known as vertex connectivity number. Is known as vertex connectivity number. That set is called vertex connectivity set. If at a graph contains cut vertex, I think 1 vertex is enough. Right? Please careful. Minimum how many vertices you have to delete. Similar way, minimum how many edges you have to delete. That is called edge connectivity number. Write that also. Write that also. Just write that. V1, V2, V3, V4, V5. Yeah, please help me. Please help me. How many edges I have to delete? So the graph became disconnected. Try one time. How many edges I have to delete so that graph became deleted. Remember, edge deleting means vertex not deleting. Edge deleting means vertex not deleting. Please be careful. If you delete edges, means edges only you are deleting. So let me write now. Set S1 is equal to E1 E2. If I delete E1 E2, graph became disconnected. Check. If I go to set S2, right, it became E5, E3, E6. Right? So this is also making graph disconnected. This is also making graph disconnected. Remember, minimum number of edges to be deleted. So that graph became disconnected is known as edge connectivity number. Right? Let me write. Edge connectivity number. Minimum number of edges to be deleted. So that graph became disconnected. Is known as edge connectivity number. And that set is called edge connectivity set. See, edge connectivity number. Edge connectivity number is equal to 2. This is edge connectivity set. Because minimum keyword, see, minimum number of edges, not number of edges, minimum number of edges to be deleted so that graph became disconnected is known as edge connectivity number. That set is called edge connectivity set. Fine. Are you okay? There may be many. There may be many. So I written E1, E2. Some people are saying E4, E5 also. But number is 2 only. Edge connectivity number is 2 only. Whether you take E1, E2 or E4, E5, right? Edge connectivity number is 2 only. So just remember the definition. Minimum number of 6 1. Only one person if I delete, graph became disconnected. Cut vertex. Only one edge deleted, graph became disconnected. Cut edge. That's okay. Cut vertex, cut edge, completed. Next one. Vertex, right? Vertex connectivity means minimum number of vertices. How many I have to delete? So that graph became disconnected. That is called vertex connectivity number. Next one, minimum number of edges, how many I have to delete? So that graph became disconnected is known as edge connectivity number. Minimum, here minimum. Only one person, cut vertex, cut edge. Minimum number of vertices I have to delete so that graph become disconnected. Vertex connectivity number. Minimum number of edges, edge connectivity number. I hope you are really comfortable. Let me know if anyone having doubt. If you okay, I can move further. If you are okay, I can move further. Only one person, cut vertex, cut edge. More than one person, right? Edge connectivity number, vertex connectivity number. More than one person, you are more than one vertex, so that graph become disconnected. Vertex connectivity number. More than one edge, so that graph become disconnected. So that is called edge connectivity number. Are you okay, Bhaiya? Bhaiya, are you okay? Bhaiya, are you okay? If you okay, can you see the next story? If you okay, can you see the next story? Everyone observe. Can you see the next story? A, B, C, D, E, F, G, and H. E1, E3, E2, E8, some numbers, E4, E5, E6, E7. In this diagram, find out yourself, cut vertices how many? Who are the cut vertices identified? Cut edge. Who are the cut edges identified? Next one. Edge connectivity number how much? Vertex connectivity number how much? Can you go ahead? Those people who are having doubt, you can rectify here. Sir, I have this doubt. You can rectify now. Who are the cut vertices? Who are the cut edges? Right? What is the edge connectivity number? What is the vertex connectivity number? Can you please go ahead? Can you please go ahead? Yeah. So you only say Atul, you only say vertex is not there, how edge will be there? You only say vertex is not there, how edge will be there. So it is something like this. It is something like this. It is something like this. You only say, I deleted A here, B here, C here. I deleted B, but edges are there. What is the meaning? I deleted B, edges are there. What is the meaning? Sir, in cut vertex, we are deleting vertex and edges also. But in cut edge, not vertices. Right? So you no need to do because, right, because of one edge, you cannot delete vertex because that vertex may be having other edges. Right? See this one. Because of this edge you are deleting, you cannot delete vertices because he may be having some more people. He may be having some more people. Are you getting? Right? Fine. Yeah, can you complete this problem? The problem which is available on the board. If you can do this, you will get the clarity. If you can do this, you will get the clarity. Can you find out yourself who are cut vertices? Who are cut edges? And one more interesting answer. One cut vertex also there. One cut vertex also there. I think vertex connectivity 1 or not? One cut vertex also there. Definitely vertex connectivity 1 because minimum number of vertices to be deleted so that the graph becomes disconnected. Right? Next one, cut edge is minimum 1 also there. Edge connectivity number also 1. I think let me check one small name. Cut vertex. In my opinion, B is a cut vertex. In my opinion, E6 is a cut edge. So because of that reason, it is 1. It is also 1. One cut vertex is there. One cut edge also there. Minimum number of edges I have to delete so that the graph becomes disconnected. Edge connectivity number 1. Minimum number of vertices I have to delete so that the graph becomes disconnected. That is called the vertex connectivity number. Right? But I have to find out all cut vertices. I think B is a cut vertex. I think F also cut vertex. I think C also cut vertex. I think G also cut vertex. I think D also cut vertex. Check. B also, F also, C also, G also, D also. Total, I think total 8 people are there. I think 5 people. First 2 and the last H. Let's go to cut edge. I think E6, I think E1 also, E2 also. I think E8 no problem. E7, E3 no problem. E4 no problem. E5 is the problem. E6 problem already we written. E7 also problem. E5 having problem. E6 having problem. E7 having problem. E4 no problem. E3 no problem. E8 no problem. Minimum number of edges I have to delete. Graph become disconnected. 1. Minimum number of vertices I have to delete so that the graph become disconnected. 1. I think, are you comfortable this? Are you comfortable this? Someone is saying, if they ask for cut vertex, na? Cut vertex means, right, articulation point. Cut vertex means articulation point. Arey bhaiya, cut vertex. See the definitions. See the definitions. See, it's a cut edge. Cut edge means one edge. Be careful. Cut vertex. One vertex. The cut vertex. The cut edge, which is also called articulation point and bridge. Fine. Jaya, are you fine? Yeah, fine. Next one. Suppose in the cut vertex is available, right? Vertex cover, right? Vertex connectivity becomes 1. Suppose cut edge is possible. Edge connectivity becomes 1. Okay, you are almost comfortable. Let's go to one more problem. Let's go to one more problem. You may get more clarity. Let's go to one more problem. You may get more clarity. One more example. Can you take this? A, B, C, D, E, F, G, E1, E2, E1, E2, E3, E4, E5, E6, E7, E8. Find out yourself. Find out yourself. Cut vertices. Who are cut vertices? Who are the cut edges? Next one, edge connectivity number. Vertex connectivity number. Please go ahead. Vertex, what is the answer? No one? No. No cut vertex, no articulation point. Right. Is there any cut edge? Is there any cut edge? Cut edge? No cut edge. No bridge. Can you help me now? What is the edge connectivity number? Edge connectivity number. Minimum number of edges we have to delete so that the graph becomes disconnected. Right? Minimum number of edges so that the graph becomes disconnected. Or minimum number of vertices so that the graph becomes disconnected. Can you help me one small line? If you delete this person, if you delete this person, if you delete this person, graph becomes disconnected. Check. If you delete A, if you delete A, if you delete E, graph becomes disconnected. Vertex connectivity number 2. 1 not possible. Edge connectivity number. I think if you delete this edge, if you delete this edge, graph become disconnected. Or if you delete this one, if you delete this one, graph become disconnected. Right? So, right. So, what does it mean? Cut vertex. Cut vertex means by deleting any vertex, graph become disconnected. Then that one is called cut vertex. Or articulation point. Move to the next one. Right, move to the next one. I think we completed all these things. Right, come to the next one. One more problem. One more problem. Those people who have doubt, I think they can clarify again. One more chance came. So can you see this? Yeah, next problem. One, two, three, 4, 5. 1, 2, 3, 4, 5. Yeah. Try your level best. What is the answer for this? For this one, what is the right edge connectivity number? Edge connectivity number of the given graph. Vertex connectivity number of the given graph. Can you complete this? Yeah, what is the answer for this problem? So edge connectivity number, how much? Yeah, first find out vertex connectivity number. Vertex connectivity number, how much? Because of it is a complete graph, I think because of complete graph, how many people I have to delete? Because of it is a complete graph, how many people I have to delete? I think I have to delete all. I think it is not possible. Fine. Am I right? No, if you delete n minus 1 also, lastly one left out. Graph not disconnected, na? No. No, am I right? Am I right or not? Because of it is a complete graph, if you delete all the people also, lastly one person left out. Still it is not disconnected. There is no problem. Next one, what about edge connectivity number? I think it is a complete graph. I think in my opinion, you have to delete n minus 1. It is a K5. I think 4 people you have to delete. Fine. 4 people you have to delete. No, na, 4 edges you can delete. So graph became disconnected. When you say edge, right? When you say edge connectivity number, edges only you have to delete, not vertices, right? Not vertices, right? Right? Not vertices, right? Please take care. So that is the answer for this. Now one more problem. One more problem. 1, 2, 3, 4, and 5. Yeah, to this one, find yourself. What is the edge connectivity number? What is the vertex connectivity number? Edge connectivity number, vertex connectivity number. So what is the answer for this? So for this one, if you observe vertex connectivity, how much? What is the vertex connectivity number? What about vertex connectivity number? So can you help me now? How many vertices I have to delete so that graph become disconnected? How many vertices I have to delete so that graph become disconnected? How many? How many vertices I have to delete so that graph become disconnected? I think if I delete this vertex, right? If I delete this one, all will go. If I delete this one, all will go. Yeah. Can you guess what is the answer? What is the vertex connectivity number? Someone is saying 3. Totally 5 people. Totally 5 people. Someone is saying 3. Let's check once. This is gone, assume. Okay. Next one. This is gone, assume. This is gone, assume. Right? I think whenever this is gone, Those people who said 3, how 3? What I have to delete? Can you say? Those people who said 3, what I have to delete? Someone said 3. So I think this may be the case. Someone said 3, this may be the case. Delete him, delete him, delete him. I think 3 correct. Can anyone help? What about edge connectivity number? Edge connectivity number. Edge connectivity number. How many edges? I think this 3. Right? Fine. Perfect. I hope you got the answer. I hope you got the answer. So let me check once. One more diagram. Last diagram. Can you see this also? Can you see this also? Last diagram. One more example. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. This is going to be like this. Yeah, it is a given graph. It is a given graph. Identify yourself. Edge cover and vertex cover. What is the answer for this? Please check. Complete this also. Over, almost over. Just be comfortable with the definitions. I am not done anything. I am not done anything. Be comfortable with the definitions. Be comfortable with the definitions. Name itself saying cut vertex means one vertex which is cutting, one edge which is cutting, right? So these are the two things which are important. Edge connectivity, vertex connectivity. Can you complete this? Only for name's sake, for your convenience, I am giving these problems. Can you do one time? Can you do one time? You will get the clarity. Because there is a one small confusion is there. I will do that. Until here, you are okay. Can you see this yourself? Yeah. What is the answer of this problem? I think totally 4 problems I given. Totally 4 problems I given. Please check one time. Please check one time. So, what is the vertex cover? Sorry, vertex connectivity for the given graph? For this problem, first problem here. What is the vertex connectivity for the first problem? Minimum number of, right, vertex connectivity, minimum number of vertices I have to delete so that the graph become disconnected. So what is the answer? I think 1. This one you delete. What about the edge connectivity number? Minimum number of edges I have to delete so that the graph become disconnected. 1. This edge you delete. Okay, come here now. What about this? What about this? Complete all these people. So what is the answer of this diagram? What is the answer of this diagram? Edge connectivity number. Minimum number of edges, how many I have to delete so that the graph become disconnected? 2. These 2 delete. Next one. What about the vertex connectivity? Minimum number of vertices, I think 1. Now, because of everyone is comfortable, lastly, one question I want to ask everyone. Vertex connectivity number, edge connectivity number. Who can be more? Give answer only for this. By seeing all these examples, can you help me? Vertex connectivity number, edge connectivity number, who is more? Mostly edge connectivity, because when you delete a vertex, their edges also will go. When you delete one vertex, see, I deleted one vertex. Observe, I deleted one vertex. So many edges will go. So many edges will go. So that is the reason one vertex internally contains so many edges. But in the case of edge connectivity, we have to count edges. Remember, comparing vertex connectivity, edge connectivity number, it is always guaranteed. Either both will be equal. If you want, you can see the previous problem. Either both will be equal. Or vertex cover number, right? Vertex connectivity number will be less. Either both will be equal or vertex connectivity number is less. Can you see? I think here may not be possible. So can you see this problem? Vertex connectivity number of this graph. Yeah, I think, see, can you come here now? Vertex connectivity number, edge connectivity number. See, it's not possible. Not possible, we cannot do anything. If it is possible, we are discussing if it is possible. Vertex connectivity number is smaller, edge connectivity number is bigger. If it is possible, not possible, we cannot do any comparison. See this. Both are equal also, okay. Right? Come here. Come this problem. What is the answer? Edge connectivity number, vertex connectivity number. I think here 1. Graph become disconnected. But what about the edge connectivity number? I think this is also 1. One edge you can delete. Now come here. Now. What about the vertex connectivity number? I think it is 1. What about edges? Can we say what about edges? I think 3. Any 2 chance? Anything 2 chance? No. And one more. I want one more thing also. What is the minimum degree? Can you see in this graph minimum degree? What is the minimum degree of in this graph? I think 3. Minimum degree I am asking. Minimum degree 3? Yes. Can you go here also? What is the minimum degree here? 2. Minimum degree 2. So you only say one small question I want to ask you. Listen, one small question I want to ask you. You only say. You only say. Very interesting answer. Very interesting answer. If at all minimum degree 2, see this one. Everyone listen. Minimum degree 2. If I delete these two edges, graph become disconnected. If the minimum degree is 2, see this one. Minimum degree is 2. If I delete these two people, graph become disconnected. But there may be a chance that edge connectivity number 1. One edge you can delete also. So remember, minimum degree is 2 doesn't mean that I have to delete always two edges to get the disconnectivity. There may be a chance that edge connectivity number 1. But comparing edge connectivity number, vertex connectivity number is less. So by seeing observation on, see, out of these three people, vertex connectivity number is smaller. Edge connectivity number is middle. Right? Min degree is maximum. So careful. So this is the final formula for this one note. To say this note, I given this example. See, vertex connectivity number of the graph is less than or equal to edge connectivity number of the graph is less than or equal to, right? Minimum degree of the graph. Minimum degree of G. This is the formula. Please take it. For that formula purpose, I given many examples. For that formula purpose, I given many examples. Right? Fine. Perfect. Okay, fine. Can we go further? Can we go further? Anyone having small doubt, let me know. See, all examples I given. All examples, see. Sometimes, some people are asking, sir, why you written equal? Sometimes equal. If you want, you can check here. Minimum degree also 3. Here, min degree also 3. Right? So, I think, see, here min degree. Here, min degree, if you observe, 1. Next one, here min degree. Here min degree if you observe. Here min degree if you observe. What is the min degree in this problem? I think 2. Yeah, 2. Right? By seeing all these things, this is the observation. Vertex cover, right? Sorry, vertex connectivity number is smaller or equal to edge connectivity number, smaller or equal to min degree. So from the last half an hour to 1 hour, I am discussing this only. I am not done anything new. I am not done anything new. Right? Fine. Perfect. So cut vertex means right the vertices which are cutting, right? So articulation point and bridge. Okay, fine. That is also okay. Can you go to the next one? Can you go to the next one? Right? However, he may give new definition. Right? However, he may give new definition. Please follow whatever he will say, follow accordingly. Right? Whatever he will say, just follow. Right? It is very simple. Whatever I said, please learn. If any new definition is given, please follow that also. That is also correct. Right? Instantly, he will change the definition. That is also correct. Now, come to the next one. One small keyword is there. I will cover that also. With this, it is over. Right? One small keyword is there. I will cover that also. Just give me 1 minute. So, just one small keyword. Right? Cut set. Cut set. Right? What is the meaning of cut set? I will try this. 1, 2, 3, 4, 5, 6. Let's take this example. Definition, one example. More than enough, yeah. It is a graph. Let's give numbers. Let's give number. For every edge number required, give the numbers. E1, E2, E3, E4, E7, E8, E9, E5. What is the missing number? E1, E2, E3, E4, E5, E6, E7, E8, E9. Okay, perfect. Until now it's okay. Until now it's okay. Now listen. Now listen everyone. Now listen everyone. Cut set 1 is equal to. Observe properly. Cut set 1 is equal to. Just remember the definition. Right? I will write the definition also within a few minutes. Cut set 1 is equal to. Cut set 1 is equal to. See the answer. Cut set 1 is equal to. Can you help me now? If I delete, give the answer to me. If I delete E1, graph become disconnected. If I delete E1, graph become disconnected. Just complete this also. This small part also complete. See the definition. I will write the definition within few minutes. So if I delete edge E1, graph become disconnected. No. If I delete E3, graph become disconnected. E1, E3. If I delete the E1, E3, graph become disconnected. Remember, this is called cut set. Cut set means set of edges. If at all at anywhere, if you see cut set, remember the set of edges. Cut set is set of edges. By deleting whom graph become disconnected. Graph became disconnected. Is known as cut set. Cut set is set of edges by deleting whom graph became disconnected is known as cut set. Right? That is the one thing. And note, however, I am saying to you, he may change the definition. He may change the definition, please careful. He may change the definition, right? If he don't say anything, whatever I said, follow. If he change the definition, follow whatever he will say. Right? Cut set definition. Set of, remember, cut set means set of edges. Or subset of edges. If you want to get it, subset of edges by deleting who graph became disconnected is known as cut set. Note. No proper subset of. No proper subset of cut set is not a cut set. Or if you want, you can remove the no. Because I kept the not lastly. So you can write this one. Proper subset of a cut set is not a cut set. What it means, I will explain. Just take definition as it is. Subset of edges by deleting whom graph became disconnected is known as cut set. Next one. Proper subset of a cut set is not a cut set. What it means, I will write further, you will get the clarity. So example 2. Cut set 2. See the answer. Cut set 2. Everyone, can you catch this? Cut set 2. What about this? E8, E9. Is it cut set? E8, E9. Is it cut set? You are almost okay. E8, E9. Is it cut set? E8, E9. Sir, it should be as minimal as possible. So this is the definition. See the cut set definition. So that's what I'm saying. Hidden, they may give in the examination different definitions. Different definitions they will give. right? It's keep on changing, book to book keep on changing. You no need to bother. In examination, they will define. If you want, you can see after today's class over, see the previous paper. They will give the clear definitions. See the previous paper. I am no one to say to you, you are no one to say to me. Everything will say previous papers. Previous papers will say everything, right? You see the previous paper, any doubt there, we will discuss. Whatever I am saying, just follow that. Cut set. Subset of edges by deleting. Subset of edges by deleting whom graph became disconnected is known as cut set. Now see the definition. Proper subset of a cut set is not a cut set. Now see this one. E1, E3 if I delete, graph became disconnected. So CS1 is a cut set. Next one. If I delete E8, E9, graph became disconnected. That is also cut set. See the one more thing. One more thing. Can you see this one? Can you see this one? One more thing. One more thing. See the answer. One more thing. One more thing. Everyone have to observe. Everyone have to observe. E8, E9, E8, E9, E7. You have to understand one small line. You have to understand one small line. Please listen this. Please listen. E8, E9, E7. E8, E9, E7. Is it cut set? E8, E9, E7. Is it cut set? So I'm saying one thing. CS3 is a cut set or not? CS3 is a cut set or not? CS3 is a cut set or not? There may be some unnecessary part, but is a cut set or not? There may be some unnecessary part. Is it a cut set or not? Some unnecessary part may be there, but it is a cut set. See, can you check one time? E8, E9, E7. If you delete them, graph anyhow going to be disconnected. E8, E9, E7. Graph anyhow going to be disconnected. Right? Graph is anyhow going to be disconnected. Fine, are you getting? Graph is anyhow going to be disconnected. See this one. Proper subset of a cut set is not a cut set. Can you help me know what is the meaning of this line? Proper set, right? Proper subset of a cut set is not a cut set. Can you help me know? Is it proper subset? CS2 is the proper subset of CS3. CS2 is proper subset of CS3. CS2 is proper subset of CS3. Am I right or not? Am I right or not? So remember, either CS2 is a right cut set, either CS3 is a cut set. Any one, both cannot be. Both cannot be. Means you want to say that, right? If at all, proper subset is already cut set, it is not a cut set. Proper subset of a cut set is not a cut set. Means it is already subset is a cut set. If it is a cut set, it cannot be. So means you cannot take extra, right? The person who said, right, one of the student asked me, sir, can't it be minimal and all? Hidden, that line is came by this line or not? This is covering that part. This is covering this part. Right? This is covering that part. That part is covering here. Right? That's the meaning of that line. Proper subset of a cut set is not a cut set. If at all, it is also a cut set. So main one is not a cut set. It is not a cut set. It is not a cut set. Because if subset also cut set means it is not a cut set. That's what you want to say. Indirectly, directly. Now go to the next one. Very simple subset of edges by deleting whom graph became disconnected is known as cut set. Remember one more thing, right? One more thing, proper subset of a cut set is not a cut set. Suppose subset also cut set, superset also cut set, then superset is not a cut set because some unnecessary part you are taken. So here some unnecessary part is there, you also know, right? Fine, fine. Now I will give some more examples. You can identify who are right, who are cut set, who are not cut sets. Let's see one more thing. CS3, CS3. What about this? E7, E6, E9. Can you say this? Is it cut set? Is it cut set? See, just simply follow the definition. By deleting subset of edges, graph became disconnected, then it is called cut set. Proper subset of a cut set is not a cut set. E7, first of all, confirm. E7, E6, E9. Is it cut set? E7, E7, E6, E9. E7, E6, E9. Is it cut set? Yes. And one more thing. This is a cut set, okay. By deleting any subset, it will become a cut set? No. So I think it is a cut set. If you want, you can take any subset. It's not a cut set. Right? So that is a cut set. I think everyone is comfortable. Let's go this. What about this? Here there is no minimal, maximal. So you see the definition. This property should be satisfied. This property should be satisfied. What the meaning of this one is, right? If already someone is a cut set, is subset if I take, it cannot be a cut set. Subset itself is cut set. Superset also cut set, means superset having something redundancy. That is the meaning of that line. That is the meaning of that line. Let's try this also. E2, E3, E4, E5. Check this. Is it cut set? E2, E3, E4, E5. E2, E3, E4. Can you see this? E2, E3, E4. Already it is a cut set. What is the requirement of something else? See this one. How can you say total is cut set when this itself is a cut set? So it is not. How can you say super is right? Superset is a cut set when subset itself is a cut set? I think you are almost comfortable. You are almost comfortable. You are almost comfortable. Fine. You are almost comfortable, right? Okay, that's I think that's okay. Let's move to the next one. Let's move to the next one. Let's move to the next one. CS5. One more I will do. With this we will close it. What about E1, E3? What about E1, E3? Fine, that is also right. So subset of edges by deleting whom graph became disconnected is known as cut set. So proper subset of a cut set. Proper subset of a cut set is not a cut set. If at all anything is like that, subset also cut set, superset also cut set, definitely superset you have to cancel. Right? Next one. In all the cut set, whichever cut set's definition satisfied, whichever is minimum, I think less number of people. So it is a min cut set. It is a min cut set. Because of minimum number of vertices are there. It is a min cut set. right? So just be careful with the cut set definition. Be careful about the note also. Minimum cut set also take care. They may ask you maximum cut set. They may ask you minimum cut set. So this one, please take care. I seen in the previous paper somewhere. Otherwise, I don't say this to you. So because of cut set, because of edges are there, edges are also there. This is also called cut edges. Cut edges. Because edges are there. Edges are there. Subset of edges is subset of edges. Subset of edges. So cut edges. Not cut edge, cut edges. In the similar way, cut vertex place, cut vertices may be group. Cut vertices means group of people by deleting whom graph becomes disconnected. Right? That may be the similar story. Cut set, see here edges are there. So this is also called cut edges. Right. Yeah, anyone have, sir, CS1 and CS5 same. Let's check. I think same. Yeah, I think you can cancel one of them because anyhow same meaning only. You can cancel one of them. I will cancel this. One of them you can cancel. So, but anyhow, this is going to be a minimum cut set, min cut set, min cut set. One person you can cancel. Min, right? Cut set. Set means here edges. This is the only thing which you remember. Remaining all are normal. All the keywords are look like similar. Don't confuse. And anyone having any doubts, sir? I have this doubt, sir. Please let me. That is called vertex cover. That story is called vertex cover. That story is called vertex cover. Just write vertex cover. Topic is vertex cover. Now take one diagram. Take this. E1, E2, E3. Assume that today class is started now only. Assume that today class is started now only. No need to confuse. No need to confuse, right? Sometimes some one or two places you may be not getting, right? If you revise one time, you will get it. So assume today's class is started now only. This one, previous one, no relation. This one, previous one, no relation. Vertex cover. Right? Vertex cover. This is the problem. Yeah, this is the problem. So I will just explain little bit story. See, everyone observe. You done really nice work till now. Really, you done the nice work. Just I want answer from you. If you still remember, in the last class maybe we done. In the last class maybe we done. Can you help you now? What is the independent set? Can you help you now? No two people are adjacent. To this diagram, I want independent set. Independent set number of the graph. Independent set number of the graph. In the last class we done. Right? So I will do one time. See this one? Independent number of the graph. Independent set number of the graph. Can you say what is the answer? 1. Can you help you know? Who is the one adjacent? You have to keep other people. Adjacent people don't keep. Adjacent people don't keep. So what is the answer? Can I keep 1, 5? 1, 5. Can I keep or not? Independent set. Can you see the definition one time? Independent set. Can you see the definition one time? Independent set. Can you see the definition one time? Those people who are having small confusion also. Independent set. Can you see the definition one time? You seen definition? You seen independent set definition? You seen? Can you say 1 comma 5 is it independent? 1 comma 5 is it independent? Those two people are not adjacent, of course. Can you help? Is these two are independent? 1, 5, 3 independent. No two people. If you want to picture, no two people adjacent. This is also next. One more independent. One more independent. One more independent. One more independent. I think 3 and 4. 3 and 4. Can you say out of all these independent one, which one is the larger one? 3. This is going to be independent number of the right independent set number of the graph. If you want, you can check in your notes. We are already written independent set number of the graph is equal to 3. Is equal to 3. That is the independent set. In the last class we done. If anyone having small confusion, please go through it one time. Now come to what is the vertex cover. Now concentrate here. Vertex cover we are discussing. Vertex cover 1 is equal to, see the answer. Vertex cover 1 is equal to, remember vertex cover. Name itself saying vertex cover. Answer is vertices. Vertex cover means answer is vertices. See what I am doing. Number of edges, if you observe, 6 edges are there. Number of edges in this graph is 6 edges. See, sorry, number of edges here is 6 edges. Right? Now see what I am doing. If I write vertex 1, what happened is vertex 1 will cover. Vertex 1 you written means 1 adjacent people you covered. Vertex 1, if I write in the answer, 2 edges are covered. Vertex 1, if I write in the answer, right, there 2 adjacent people are completed. 2 edges are over. Total edges are 6 edges. Total edges are 6 edges. 2 edges are already over. Remaining edges I want to cover. See this one? See everyone now. See everyone. See everyone. If I write vertex 5, these 2 edges also covered. Totally I have 6 edges. I have to cover all edges. Now, can you help? 2 more edges are there. If I write 2, this also covered, this also covered. All edges are covered. Remember, this is 1 vertex cover. Vertex cover is nothing but set of vertices. I am writing. Vertex cover is set of vertices. Set of vertices which will cover all edges. Which will cover all edges. That's it. Vertex cover is set of vertices. Set of vertices which will cover all edges. I think this is the one answer. Can you see one more answer? Vertex cover 2. Observe clearly. Vertex cover 2. See the answer. If I write vertex 4, this covered, this covered, this covered. If I write vertex 2, this covered, this covered, this covered, and this also covered. I think all are over. This is also one answer. Right? If anyone having small doubt, check, cross check. Cross check one time. It is the E1. It is the E1. If I say vertex, right? If I say vertex 4, see this one, vertex 4, these 3 are covered. If I say vertex 2, right? This is covered, this is covered, this is covered. Same thing may cover again. I don't have any problem. That is also next one. Vertex cover 3. Can you guess one more? Can anyone guess one more? Vertex cover is nothing but set of vertices. Answer is vertices. Vertex cover means answer is set of vertices. Covering all edges. Covering all edges. Can you say one more answer? Anyone give the answer to me? Someone is saying 1, 3, 5. Let's check. 1, 3, 5. You may be correct. Let's see. 1, 3, 5. 1, 3, 5. I think when you say 1, these two are covered. When you say 3, this is covered. When you say 5, this is covered. No, no, I think one edge is still left out. One edge is still left out. One edge is still left out. Which one? I think E3, no one covered. 1 covered only E1, E2. 3 covered only E6. 5 covered only 4 and 5. I think 3 still left out. Maybe you have to take 2. Maybe you have to take 2. So careful. Maybe you have to take 2. Are you fine? Are you fine? Yeah, E3 not covered. So this is not right. You have to take one more 2. You have to take one more 2. Then only I think 3 will be covered. So I think whatever you said is wrong. So I correct it. Vertex cover 3 I written. Okay, fine. Next. Next, I think if you're really comfortable, in all vertex cover, it is the smallest one, right? So it is the smallest one. This is called minimal vertex cover. Minimum number of vertices which will cover all edges. Minimal vertex cover. How many vertices are there? 2 are there. In all independent sets, see, independent means what? No 2 people adjacent. Very difficult to keep one more person so that no 2 people are adjacent. So you got maximum person like that. This is the independent number of the graph. Right? Next one. No 2 people. See this one. If you with the help of one vertex, you are covering few edges. With the help of one more vertex, you are covering few more. So with the help of less people, you are covering more. So that is called minimal vertex cover. Now remember everyone. Everyone remember. Right? From this problem, I want to say one thing. This is called minimal vertex cover. Right? This is called a vertex cover. Number of the graph. This is called vertex cover number of the graph. This minimal, maximal, you have to remember properly. Vertex cover number of the graph. Vertex cover number of the graph is 2. Independent number of the graph is 3. If you add 2 plus 3, 5, which is the number of vertices. So I will write that number, right? Don't confuse. Vertex cover number of the graph. If you find one, another one easily will get. Vertex cover number of the graph plus independent number of the graph. Independent set number of the graph. Is equal to set of vertices. This is going to be, I think we got 3. This is going to be, we got 2. I think vertex cover, how much we got? 2. This is 2. This is 3. Which is 5. Another thing I'm saying. Can you listen? Another thing. Vertex cover number of the graph is 2. Who are those? 2, 4. Independent number of the graph, if you want, you can check. Other than those, 1, 3, 5. Other than, right, from the total vertices, remove these 2, 4. It became 1, 3, 5. Can you check over? 1, 3, 5. Right? So this is the story here. Now, those people who are having small doubt also, I will give one more example. Can you check once? With this, it is over. With this, it is over. You no need to confuse. No need to think much. 1, 2, 3, 4, 5. Don't think much. Just seeing the definition, few example checking. I am writing complete graph. Everyone knows. It's a K5. See the answer. See the answer. It is a K5. I want answer. I want very interesting one. Everyone observe. Everyone observe. Right? Everyone observe. Independent set. Independent set. Number of the graph. Independent set. Number of the graph. If you observe clearly, this one. Independent set number of the graph. Because of it is a complete graph, everyone is adjacent. You can take only one. If you cannot keep 1, 2. You can take only 2. You can take only 3. You can take only 4. You cannot take 2 people. It's not possible. So independent set number of the graph. Independent set number of the graph is equal to 1. Only one person you can do. Now come here. Vertex cover. Vertex cover of the graph. Let me check. Because of it is a complete graph, so many edges are there. See this one. Because of it is a complete graph, so many edges are there. If I take 1, see the answer. If I take 1, these edges are covered. Remember, K5 contains 5 into 4, 20 by 2. 10 edges are there. Already 4 edges are covered. Already 4 edges are covered. Right? So totally 10 edges, only 4 edges I covered. If I take 5, careful, if I take 5, these are covered. Now how many covered? Let's check here. 4 over 5, 6, 1 is a repetition, so 7. I think 3 more left out. 3 more left out. Take this. I think 4 also I took. Then 7. I think it's a 8. It is already covered. It is a 9. I think 9 only covered. 1 more left out. 1 more left out. So I covered this. I covered this. 1 more left out. Either you should take 2 or 3 because this person is no one is covered. I am taking 3. If you want, you can check. Vertex cover number of the graph. Vertex cover number of the graph is 4. You cannot get less than 4. Total, if you add 5. Right? 5. You may say that, sir, it is 1. Right? This answer should be other than that. If you want, you can verify. That is also correct. 2, 3, 4, 5. That is also correct. It is also vertex cover of the graph. You can take here 2 also. If you take 2 other than that. So it's possible. Are you comfortable? Are you comfortable? Please check. Suppose independent set answer contain 1. Right? I think vertex cover will contain other than that. 2, 3, 4, 5. Suppose its number is 1. Its number is 5 minus 1, 4. Total is 5. So this formula also take. Vertex cover number of the graph plus independent set number of the graph is equal to set of vertices. If vertex cover of the graph is 2, 4, from the V remove 2, 4, you will get 3, right? This one. Similar way here also, okay, please check. Right? So if at all it is an independent set story, right? So from the total remove 1, 2, 3, 4, 5. That is going to be vertex cover. Fine. Are you okay? Are you okay with this? The definitions, right? Minimum, maximum, you have to verify properly. You have to verify properly. If you forget also, using this formula, you have to bring it out. Using this formula, you can bring it out. There is some relation. Vertex cover of the graph, independent set number of the graph. There is some relation. One thing you learn properly. Independent set. See, independent means no 2 people adjacent. So getting more people are very difficult here. So that is the reason you are trying more. Next one. In the case of vertex cover, all edges I have to cover. All edges you are covering with less people. Less people is a great idea. All people covering all vertices. What is the use? All edges covering with less people, less vertices. So minimum vertex cover. But here, no 2 people are adjacent. No 2 people are adjacent. With that condition, I am keeping more people. So I think it is a maximum number. You have to take maximum here. You have to take minimum here. Right? So yeah, if you add them, total should come. Are you okay, Bhaiya? Bhaiya, are you okay? So I think I done the vertex covering. I done the vertex covering. There's one more line. Edge covering. One more thing. Edge covering. Edge means a line. This is also called as a line covering. With this, it is over. Like vertex covering, edge covering. When I don't say, you feel that they are very difficult. Edge covering, which is also called line covering. I will give one example. 1, 2, 3, 4, 5. Can you help me now? Can you help me now? This answer is vertices or edges? Please give answer to me. This answer is vertices or edges? Yeah, sir didn't understand the removing part. Can you go there? Removing part. Can you help me? Can you help me now? Total vertices how many? Total vertices are 1, 2, 3, 4. See this one. Total vertices are 1, 2, 3, 4, 5. Right? Now, if you see the vertex number of the graph, 2, those are 2, 4. Those are 2, 4. Now, independent set number of the graph is 1, 3, 5. How? V minus that 2, 4 you do. This 2, 4. Then you got this. From the total, remove 2 and 4. You got 1, 3, 5. That is the meaning of subtraction. You got now? Abhi, you got? That's it. Simply subtraction. Now come here. Just to do this also, it's over. Can you say edge covering means set of edges? If I don't say, you feel it's a very danger. Same thing like vertex cover. Can you come here? Vertex cover. Can you come to the vertex cover definition? See this one. Vertex cover is a set of vertices which will cover all edges. Similarly here, reverse. Edge cover is set of edges. Edge cover is set of edges which will cover all vertices. Which will cover all vertices. Edge cover is set of vertices which will cover all vertices. Which will cover all vertices. If anyone is not getting, take one example. Edge cover, EC. Edge cover. Remember here, edge cover. Shortcut I used. Edge cover, which is also called line cover. Line cover. Edge means line. I'm writing line cover. 1 is equal to. Observe clearly. Remember, line cover is set of lines. See, edge cover is a set of edges. So edges you have to write. E1, E2, E3, E4, E5, E6, E7. Right? So now see this one. See everyone observe, nothing to think much. Nothing to think much. See, here edges are there. Here edges. See this one. I am writing E1. If I write E1, E1 will cover this vertex, this vertex. If I take the edge E1, it is covering this side vertex, that side vertex. If I take E3, it is covering this side person, this side person. Totally 5 people, 4 people are already covered. If I take E5, it is covering vertex 5 also. Sorry, not E5, E7. If I take E7, vertex 5 also covered. E7 you are taking. Then definitely this is also covered. So please careful. That's it. By taking E1, there both the corners are covered, means 1, 2 covered. By taking E3, there both the corners are covered, 3, 4. By taking E7, right, both the corners, 2 and 5, 2 already covered, no problem, 5 also. This is one line covering. Edge covering is set of edges, which will cover all vertices. Of course, can you do like that one more? Can you do like that one more? Complete this. Complete this. So over, almost over. Complete. So our goal is with minimum edges. You have to cover all vertices. See, more edges if you take to cover all people, what is so great? Take less edges so that many people will cover. Take less edges so that many people will cover. So I think let me check one small line. Let me check one small line. Take the less edges so that many people will cover. So can you help me? Can you help me? If I take E4, who covered? If I take E4, who covered? Remember edge covering, edge covering. Answer is set of edges. Answer is set of edges. Please take care. Someone is saying that 3, 2. 3, 2. Then what will happen? 3, 2. Check properly. Check properly. Check properly. Complete this. Same story. Go ahead. Go ahead. One thing I already done. So E4, if I take E4, remember answer is set of edges because it's the edge covering. Set of edges. So E4 will cover. E4 will cover this one, this one. Next, I think E6 will cover. E6 will cover this one, this one. Next, I think E7 will cover 5. So one more. Yeah. Anything else? Anything else? Now I will give one small answer. I will give one small answer. Can you see? Line, right? Line covering 3. Line covering 3. Is it right or wrong? Let me check. Is it right or wrong? Let me check. Let me check once. Is it right or wrong? Let me check. See this? See everyone see one time. E7. These two covered. E7, these two are covered. Next one, E2. E2. Where is the E2? These two covered. Next, E5. Next, E5. This also covered. Yeah. Is there anyone? Is there anyone? So can you help me now? One small question I want to ask you. One small question I want to ask you. Is it right or wrong? Let's check. Else E4 is equal to whatever I am giving answer. Is it right or wrong? Let's check. Let's check once. E1, E7, E1, E7, E4, E6. Is it right or wrong? Whatever I written is right or wrong, check. So definition I already written. Edge cover is set of edges which will cover all vertices. Edge cover is set of edges which will cover all vertices. Right? So whatever I written the answer, is it okay or not? Verify once. Verify once. E1, E1. I think these two cover. E7, E7. These two cover. E4, E4. This is covered. Next, E6. This is covered. Now, one small question I want to ask you. If I delete anyone from this, if I delete any person from this, can I cover all vertices or something left? Give answer. Last answer. Last answer. If I delete any person from there, E1, E7, E4, E6. If I delete any person, if I delete any person from there, some vertices are left out or all covered? E1, E7, E4, E6. So if I delete any person, someone is saying that E1 we can delete. Is it so? Then who will cover 1? If I delete E1, who will cover 1? E6 will cover. E6 will cover. So remember everyone. Remember everyone. So in this one, if you observe clearly, in this one, if I delete E1, still it is working. Am I right or not? So remember, it is not minimal edge cover. Not minimal edge cover, because I can delete someone. Not minimal edge cover. It is not minimal edge cover. Right? So if you observe clearly, if you delete any person from this, right? I think some may be left out. If you want, you can verify. It is a minimal edge cover. It is a minimal edge cover. It is also, check one time. It is also minimal edge cover. I hope it is also minimal edge cover. You can verify one time. Because if I delete any person, something left out. Something left out. If I delete anyone, something left out. Check one time. If I delete anyone, something left out. So these all are the minimal edge covers. This is not minimal edge cover. Next one. In all minimal edge cover, right? In all minimal edge cover, whichever having less edges, that person is called as, right? That person is called as, right? Edge cover number of the graph. Edge cover number of the graph. Minimum person among all of them, minimum whoever is there, that person, minimum, right? That person is called edge cover number of the graph. He is having 3. Suppose someone having 4. I think let's try one more. LC5. I will try. 4 people, but still minimal. Can you check? 4 people still minimal. Can anyone help me? 4 people still minimal. Let's try. Let's try E2. I want 4 edges still minimal. So E2 means these two cover. Okay. Next one, E3, these two cover. Okay. Next, E1, this is also covered. Next one, E7. This is cover. Is it okay? Is it okay? Is it correct? So remember, this is also minimal edge cover. Minimal edge cover. This is also, because if you delete any person, no more it will satisfy. But here 4 edges are there. Check if I done anything wrong. Someone is saying that E1, E3, E7. Check once. E1, E3, E7. E1. So can you help? Is first one, fourth one same? Someone is saying 1, 2, 5, 7. Let's go for 5 then. 1, 2, 5, 7. 1, 2, 5, 7. Check. First 2, next 5, next 1, next 7. Okay, fine. So this is also minimal edge cover. This is also minimal edge cover. This is also minimal. This is also minimal. Among all of them, minimal, right? Among all of them, whichever is minimum. So that minimal contain, I think, 3 people, 3 edges. That is called, right, edge cover number of the graph. Edge cover. So you may say that, sir, should I take minimal or maximal? What is your goal? Covering all people with less edges. Covering all vertices with less edges. Less edges is good. So minimum edges. Take minimum. Take minimum. So I think this is also vertex cover also same. That is also minimum only. That is also minimum only. Among all the people, minimum. Among all the people, minimum. Right? Fine. Here also minimum. If you want, you can check minimum. It is a 2, it is a 4, so minimal is 2. So here also, same way I done here also. If anyone confused, same here also. Vertex covers to find out. Right? So vertex covers to find out. Vertex cover find out. And one more. If I delete anyone, right? If I delete anyone, some edges are left out. If I delete anyone, some edges are left out. So these all are going to be minimal vertex covers. These all are going to be minimal vertex cover. Out of all of them, whoever is the small, that is going to be, right? That is going to be really minimum. That is going to be vertex number of the graph. Similar, whatever you done here also same.